I think they are still reading the problems, but every team should have one member who is typing their template. But I think they should have completed the template.
Okay, now on the screen we are seeing one team on the far side, the contestants just changed their seat with each other, so probably they have finished the first problems thinking process, and they it seems that they could be starting to type or maybe just type in the templates required for the problem. Yeah.
I just received the problem statement, so I will start to have a quick look at every problem.
As the same as the contestants, we now have our problem set, the same problem set as the contestants get. Okay, so now maybe we should start reading the problems first.
I remember that last year the first solution appears after about 10 minutes, so we need to wait some time.
Wow, 10 minutes, really? But okay, so that is almost the same as I think last year's World Final. In the last year's World Finals, the first solution that got accepted or a yes from the judges was also around 10 minutes mark into the contest. So probably this year the standard are up to the World Finals level.
I'm surprised that there is still no any submission now. I saw some team may submit some random submission for some effect. Oh, but it's a serious contest, they should not do that. But that means all problems seem to be very hard.
Yeah, currently still no submissions on the queue, so we're seeing some people asking in the chat that they are not seeing the scoreboard. Yeah, the scoreboard does not have any team that has a submission. Yeah. Currently, all the teams are first place. It's only we're only 8 minutes into the contest. So today we have 13 tasks for the contestants.
Oh, there is a submission.
Oh no, yeah, we saw the first submission and that one is a no on problem A. So probably the problem A
there's another
is
for
the
problem K.
easiest. The problem K from HC
Oh, it's the first solution.
Alia Yaktarist. The team from Vietnam got their first spot and they are now in the first place of the scoreboard. So all the other teams are now second place, and let's see who can level here. Okay, on the screen we're seeing the team screen from the team HCMUS Area Yaktari East. And this year we're using Don't Judge as the platform.
They are watching their achievement.
Yeah.
There's a dark green cell there.
The dark green cell in the scoreboard or team's profile means that is the first to solve to any problems, and also the first to solve to that specific problem. If you're not the team first to solve a problem, but you still got the yes from on that problem, you will see a slightly lighter green there. And in this profile, you would see how many attempts you try on that problem before you got a yes, and also the time or the penalty you got on that problem. So here's how the ranking is decided. First, we rank the teams by how many problems they solved. So of course, the teams that solve more problems would be on the top, and the teams that solve less would be in the bottom. Yeah. So now we are going to show the first solutions balloon. Is this the correct one? Yeah, they have the gold A there, and I think there are now 2 yeses. The blue one, or not. The blue one is for problem. I think it's for problem.
This is for problem K.
K. So the first to solve teams will get 2 burdens for that solution.
Yeah. There will be an alphabet one. Very cool.
So a special one and a normal one. Okay, now we have Rinshan's solution. Also got a yes on problem K at 10 minutes. They are almost 2.5 minutes later. So the team Area Yaktari really was super fast. On recognizing the problem K is easy, and also the coding was super fast. Now we got a third yes from the judges, and that one is Team Strong Zero. They are the regional winners and represents National University of Singapore. So they are now leading in their competition against the other team from their university, and that is Penguin and Tonic. Remember that each university can get only 1 ticket, and so only 1 team in that university will be advanced to the World Finals. And yeah, since they are the regional winners, the National University of Singapore has already secured 1 ticket. The problem is which team the ticket will go to. Okay, so now we are looking at the team screen of the Team Strong Zero, and as you can see on the screen, they are trying to solve problem H. So I think that's quite fast. Immediately after solving problem K, they started to work on problem H. So is this a easy problem too? Have you read the problem statements yet?
I read problem K. I think it's quite easy. Other teams should solve it in a short time after they see 3 teams have got a safety on it.
Yeah. So the scoreboard here that we can see in our screen, or the queue we can see on our screen, is that every team can see it inside the contest area. So any team solving any problem, they got a yes, they got a no, all the teams can see it. But there's one constraint. It is not that the whole of the 5 hours contest we are updating the scoreboard. At the 4-hour mark, the scoreboard will be frozen. So anyone submitting anything to any problem in the last hour will not be updated in the public scoreboard for the contestants. All right, so they are trying the problem HS and they got a yes. So they are now the first place teams with 2 problems solved. That's quite a strong start because the other team from their university is still at 0. So it's 2-0 now. And this could be a huge lead at the early stage of the contest because earlier we said that the team solving more problems will be on the top. That is for sure, and I think quite straightforward. But what if the teams are tied on the problem solved? Then we will go to the penalty or the total time consumed. So how does this compute? It is based on the sum of the time for all problems that you consume to get a first yes on that problem. So let's take an example. In the top of the scoreboard, we're seeing strong 0 with 2 problems solved and penalty is 25. That is because they used 14 minutes, or we should say they got a yes on the edge at the 14 minutes mark, and also 11 minutes for problem K. So it is 11 plus that 14 resulting in the 25. And for other teams, they have only solved 1, so the penalty is the time they used. But we will have another 20 minutes penalty for each incorrect attempt. But okay, so I think it's which team is this?
I think it's strong 0.
Oh yeah, strong 0 for problem H. We can see the gold and big H alphabet balloon. And we're seeing, I think it's our chief judge and also our directors taking pictures behind the team. Yeah. So let's continue the explanation for the standings and how the penalty is computed. So currently we're seeing down in the middle that the team Chalo has a -2 in the scoreboard. That means they have 2 incorrect attempts. But the penalty is still 0. That it is because they haven't solved the problem yet. Currently it's 18 minutes into the contest, so should they solve the problem now, their penalty will be 2 20 minutes penalty plus the 18 as the current time. So that if they solve the problem now, there will be 1 problem solved and 58 minutes penalty. So how do we rank is also quite straightforward here. The team that gets less penalty will be on the top. So that 20 minutes is really a huge penalty if the teams are neck to neck at the end of the contest. So right now we are looking at which team is this? I think it's Penguin and Tonic. As you can see on the bottom right of the screen, they are currently in ninth place, but I think all the teams that haven't solved any problems are in the ninth place. That means we have 8 teams already at least one solved. So they are working on problem J, and that is quite different from the other teams because we're seeing other teams getting their problem H and K accepted. But this is problem J. So probably H, J, K are the easiest problems in this contest. But the code is, it seems the codes are quite long. It's already like 70 lines. And they are having a lot of ifs here. Okay, so now we have another team, drop table tennis. Drop table team. I forgot their name. Sorry. Drop table teams, not tennis. Sorry. The team from UNSW Sydney and their first place team in the South Pacific Independent Regional Contest. They are trying to solve problem J. Well, they have already secured a ticket to the World Finals, but they still can fight for the Asia Pacific championship. It will be a special award for them, as we haven't seen any of the teams from South Pacific winning the Asia Pacific championship. So we already seen 2-3 teams having a different approach to the whole problem set of in terms of which problem should be solved first or considered as the easiest. Have you tried to figure out what the problem H or K wanted us to do?
I read problem H, J, and K. K is just a simple problem which can be solved with simple enumeration. Maybe we can.
Yeah, let's try to solve it.
Okay.
Wait. Before trying to solve it, maybe we should explain what the problem wants us to do and also the constraints first.
Okay.
So it's your time.
Okay. The problem K. I think I can share my screen. Wait a second.
Yeah, let's share the screen. Yes, let's share the screen and show people the problem K, if possible.
It should be possible, but there's a maybe solve some technical issue.
Yeah, we need to. Yeah, no hurries. No
Okay.
hurry. Okay, now we are seeing a team. The team NEU Anarchials, they got a yes on the problem J, and that is the first to solve.
Oh wait.
So that means we have 3 different problems. We got teams on the board. Yeah, so
Okay, we can see the problem statement now.
你看到他们开始送的时候，把那个荧幕换掉，然后先讲一下，然后把它换掉。Wait a minute. Let's focus on the balloon for the problem J first, and then we will continue to the explanation of problem K. So here we're seeing the first solution balloon, which is a special super big alphabet J, and also a green balloon that represents the problem J. And in the meantime, we're seeing there are teams trying problem B, but they got a no. And the WA in the bottom right of the screen in the queue, that stands as wrong answer, which means your program can get the input correctly and also can terminate correctly or without any problem. Let's not say correctly. But the output is wrong answer. So that means something is wrong in it. Yeah, so let's get back to the problem K.
Okay, the problem has n stickers, and each sticker is a single digit from 0 to 9. And our goal is to create time displays using these stickers. And each time display is in a format, is hour and is minute. Hour is 2 digits between 0 to 11. If the hour is a single digit, we must use 2 stickers, which one of them is 0. And the minute is also 2 digits, and also we should remember that if the minute is a single digit, we should still use 2 stickers. Then we want to make some time displays and use these given n stickers, but each sticker can only be used for at most one time display. Oh, what's the input format? The second line contains a string S. What is string S? Oh, I think the string S is a string of length n, and each character represents what each sticker is. Okay, so I think it's too easy for the judge, so we can simply explain. My first idea is to enumerate the number of time displays with hours 11 and 10 and 11 and 12. Oh, but oh, then I know I need to use some the key point is that we cannot use arbitrary numbers as the hour, but we can. The minute part is easier because we can always use any number as the lowest digit, and its 10th digit is 0 to 5, so that's easier. But for the hour part, it's different if we use single digit or 2 digits.
I think it's 00 to 11. So if you put the first digit as 0, then you could put any of the any
Oh yeah, right.
anything in the second digit. But if it's 1, then it's only 0 or 1 in the second digit. But you cannot put any of the 2 to 9 in the first digit. Right? So I wonder if maybe we can try to look at how many zeros and ones we have. Because for 0 in the first digit is anything in the second, but for 1 in the first is 0 or 1. So I think the number of how many zeros and ones we have should be crucial.
Oh, do we need to make sure that all time displays are different, or it's okay if they are the same?
I think they can be the same.
Oh,
So
that would be easier.
yeah, it's just arbitrary and valid times that you can produce, because it only asks within the given stickers what is the maximum number of the time displays you can create. It doesn't state that the time displays have to be different.
Also, we don't need to let the hour be 10 because 0, 1 is always possible.
Yeah, you may just use 0, 1, but sometimes you would want to use like 0, 2, 0, 3 or all the way to.
Oh yes, so the solution should be we enumerate how many 11 we have for the hour, and we know we at least need to use some 0 for remaining time displays, and other digits can be arbitrary.
Yeah, maybe we can. I think maybe we can try to analyze how many 0 and 1s, or maybe like 2, 3, 4, 5, because the minutes. You can use anything from 0 to 5 in the first digit and anything in the second digit. So I think we don't need to care about the second digit for the minutes. So maybe we only need to consider the first 3 digits. And if the first digit in the H is 0, then it doesn't matter what it is in second. But
For me, I will just use a binary search to find the maximum number of time displays.
binary search.
Yeah.
How? Because that's quite interesting.
So let me show the pen. If we want to let the answer be n's, then we need to, and we assume that we use x11s. Then we need to use at least n's minus x zeros and n's minus, oh no, not least, at least n's, oh too many n, at least n's 0 to 5, which is the first digit of the minute, and at least n's another 0 to 9. So we can let the answer be at least n's. We just need to check if we can do this.
So would you please demonstrate with the sample inputs and outputs of
Oh sure.
how you can like make sure your solution is correct? I mean, by passing the sample input, it is a strong signal, but not really that strong because we also have hidden test cases. So you need to really ensure that your solution is correct to be able to get a yes from the judges, right? So maybe we can try to demonstrate your solution with the sample.
So for the first one, it tells us the answer is 1, so let's check if the answer can be 1. So we need to use, we need to first enumerate how many 11 we want to use. But there is only 1, so we can only use at most 0 11, so no 11 here. Okay, so we need to use 1 0. Oh, I missed a part that is the second digit of the hour, so we need to use more s minus x 0 to 9. So this should be x plus x minus x. I think that's all. Okay, so let me go back to here. Okay, we need to use 1, 0, and 1 digit from 1 to 9, and 1 digit from 1 to 6, and 0 to 5, and another digit from 0 to 9. The second digit of the hour can be 0 to 9, so obviously we can make one-time display. This is a very easy case. And the second one, there is only one 1, so we still cannot have any 11. But we can make 2-time displays because there are 2 zeros here. So they are sufficient for the 2 hours part. And we need to use 2 digits from 0 to 9 and 2 plus 2, 4 digits from 0 to 9. We can use for like 1, 2, 3, 4. Or we cannot use 1, 2, 3, 4 because we need 2 digits from 0 to 5. So we can use 1, 2 as the first digit of the minute part. And others can be used arbitrarily. We just take 4 arbitrary numbers. So we can make 2-time displays. The third simple test case looks more interesting because it has many 11s. So we must use some 11 because there is no 0 here. Okay, so we can take at most 2 11s. Actually at most 3, but we cannot make 3-time displays since there are only 2 digits left. Okay, if we use 2 11s, the minute part can be 2 19ths. Okay, so we can use 2. And the final one is 0 because we cannot find any 11 here, and there is also no 0, so we cannot make any time displays. I think my solution should be correct.
Yeah, it does sound correct because it sounds like you're trying to solve the problem with a greedy approach that is.
Oh no! I solved it with
really?
binary search, so I assume
Really?
the answer to be some number.
Yeah, I forgot.
And I check if I can
it's the binary
make
search.
so many
Okay.
numbers.
Yeah. Let's continue.
Okay.
And maybe you should try to prove that your solution really is correct. Because it seems that we can pass the sample cases, but as we mentioned, there are a lot of hidden cases you still have to pass. So you really have to make sure that the solution is correct.
Yeah, I always prove my solution before I submit the solution. I think this problem is quite simple because the concrete condition is that first the number of 1 is at most 2 times x, so we have so many 11s, and we must assume that we don't have removed so many 1s, and then check number of zeros is at least x minus x. So this is the first digit of our part. So it's here. And then 0 to 5 should be at least, I should close the touch feature. What should it be? Nth, because we need to use, this is the first digit of the undo. Here, less ambiguous. Here. We should check this condition sequentially, and once we use so many digits, we remove it from the number of zeros, so these numbers cannot be used in the following conditions. So we actually minus the number of zeros by this number.
Yeah, wait a minute, because we're seeing
Okay.
the burden for the proper
Oh.
E. Yeah, we're seeing the problem E that we have a team solve the problem E. That is also from Vietnam, HCMUS Thai family, from University of Science VNUHCM. But currently they are the third place within their institutes. They have 3 teams. So, and now we're seeing the team Engen from Yonsei University getting the ES problem C that is also first to solve on the scoreboard. So currently we have 5 different problems that have at least one team solved it. Yeah, so shall we get back to the problem K?
Okay, we're almost done. So let's go back. Why am I writing? Eraser. Oh, it's so big. Okay, this should be at least s plus s minus x, and that's all we can see. We must use so many digits, and that should be sufficient because we just simply distribute each digit to their parts. I believe this is a sufficient proof. Okay. So I won't explain other problems so in detail because we have some judges that will. Eh? Oh,
把画面关掉，让它拍 C 的气球。
okay. Later we will have some judges to explain the solutions to us. So
Yeah,
this is the only problem that will explain by me.
Yeah, so now we're seeing the balloons for the first solution. Problem C, which is the 5th problem being solved by any teams. I think maybe after this, I can also provide my approach to the problem case, and that should be a quite different approach. So, same as the previous first to solve problems that we have our directors taking picture with the team. Yeah, so on our screen, we're getting back to the problem K, and I will provide my approach, which should be a little bit different from Wiwi's solution. And yeah, so I will focus on 4 categories of the numbers. First is the number of how many zeros we have. And in the second category is how many ones we have. Then it is how many 2, 3, 4, 5 we have as the third category. So it's the total number of 2 to 5. Then it is 6 to 9 as our fourth category. So maybe we should look at our sample cases. Could you please help me to roll the screen? No, just show the sample cases. It's fine. Yeah, thanks. So we will first try to use as many ones and zeros first in our HH positions. But one is the primary. So we try to check how many ones are there, and we will greedily use as many ones in the first position of the HH first, in our position first. And then we will try to put in the second H position with as many ones as possible. And if we don't have enough ones, then we will try to put zeros or odd numbers if that first position is 0. So firstly, we try to put as many 1 ones as possible. Then we try to put as many 1 zeros. Of course, there's only 0 or 1 zeros possibly here. Then we would try to put as many zeros in the first positions of H first. And since we have 0 in the first position of H, we can have any number in the second position of the H. So for the first case, we have 1 and 1 zeros in it. We will try to put first we will try to put 1, but we have only 1. So we cannot put 2 ones here. Then we will try 1 and 1 0. So 1 0 goes to the HH position. Then we try to check how many. We try to check if it's possible for the MM spots. So we have 4 digits of 2 to 5 in total, and also 4 digits of 6 to 9 in total. So we can have 1 of 2 to 5, any number of 2 to 5 in the first position of the M. And then in the second position of the N is anything should be okay. Or this, I should not say should be okay, it's definitely will be okay. So for that case, it is 1 possible time displays. So for the second one, the second sample inputs, we also have only 1, but we got 2 zeros there. So we will try to put that only 1 in the first position of the H. And since we don't have any of the ones there, we have to put 1 of the zeros in that spot, that second H spot. So we used 1 0 from the 2 zeros, and we are left with 1 0. Then we try to check the MN spot here for the first set. That is 1 0 MM, and for the first M, we do have some 2 to 5s, so we just take any one of it. And any one of 6 to 9s to the second N spot. Then we will have 1 valid time display and also a 0. We don't have ones left, and we have 3 digits of 2 to 5 and also 3 digits of 6 to 9 left. So here we can use the only 0 left for the first edge spot. Then we try to check for the second edge spot. But since we have the 0 in the first spot, we can't have anything in the second edge spot. We will use one of the 6 to 9s first. So now for the MM spot, we got 3 2 to 5 left and only 2 of 6 to 9 left. So surely we can form one valid 10 display here. So that is 1 plus 1 and it equals 2, and that is our solution or our answer for this sample. So for the third set, it is we got 6 ones here, 2 9s, and no 0 and no other 2 to 5 numbers. So we can have 3 11s for the H spot. But if we use 3, then we are left with only 2 digits 9. And that means we can only form 1 time displays. But if we only use 2 11s, then we are left with 2 1s and 2 9s for the MN spots, where we can have both MN spot filled with 1 9. So we need to be careful of these cases that we're using up too many 0 1s. But that limit surely ties to the how many stickers we have. So there's a maximum limit for how many 0s and 1s we can use for the HS spot. And then we can try to check how many possible solutions are valid for the MN spot. So I think that should be sufficient. We first try to use up all the 1s, then all the 0s, and we try to use up as many of 2 to 5s in the first of N spot first. Then for all the 6 and 9s, we're just using them to fill the second position of edge if the first edge is 0, and all the position of all the 10 displays of second M. So yeah, I think that should be the solution to the problem K. Okay, so I think we should continue to other problems, or I think we should maybe check our scoreboard first. So in the scoreboard, we have the first team, current first place team just used CRT. They got 4 problems solved. C, H, J, and K, where the problem C maybe it's not that easy because we're only seeing 2 teams solving it. But H, J, K should be the 3 easiest problems that all teams, not all, but most of teams have solved at least 2 of them. Have you read problem H and J?
I read H and J. I received a slice for short statements, but I need to try to move the slice to this computer.
Do you have a complete solution here already?
Oh no.
No?
There's only statements. But
okay, so
I think it's more.
Statements.
It should be easier for the audience to read the statement.
Oh, is it provided by the judges?
Oh yeah.
Okay, then.
Okay.
Maybe we can take a look at those problem statements and maybe we can discuss them and try to solve them.
But I need some time.
But
Wait.
yeah, it is your decision to which one of H and J we're going to try first.
In my opinion, I have no idea if after I read H, I think it's a little bit hard for me.
So maybe problem J? Problem J?
Yes.
Yeah.
Though I still not
so
didn't solve it, but I think it should be easier. But The scoreboard is not like this. More teams solve problem edge.
So yeah, let us how hard the contest can be, because even we have a regional contest winner here, after reading the problem statements, she cannot decide if the problem is easy or actually if it is actually hard, or come up with a solution really fast. Yeah, so I think she's trying to get the slides into our laptop for a live stream. Yeah, so well, in our current scoreboard, we are seeing that the team just used CRT from Seoul National University. They got very quick summations in problem C and J. The C is only 2 minutes after the problem J. So they are currently in first place, but this team has actually secured the ticket to the World Finals already, being the only team representing the Seoul National University and being one of the regional contest winners. Okay, so now we're seeing the team Bogosult from Kyoto University moving up to 7th place. We're now 55 minutes into the contest. Well, maybe we should explain the statistics that you're seeing on your screen. So we're listing all the problems here, A to M, and there's a graph, or there are bars showing how many teams solved the problem, how many teams have attempted the problem but not yet received the judge's response, if their codes, if their programs are accepted or not. That would be in yellow, and in the red is incorrect attempts, or we can simply say the judges doesn't feel or decides that their program is not acceptable. So they will reject the solution. So currently we are seeing 55 teams. They passed problem K, that is already more than 80% of the it's just close to 80% of the teams of the all 70 teams. Now we are having 59 teams solve at least one problem, and we still have 11 teams struggling to get their first yes. But everything can happen in a super regional championship, because we have 3 elite members every team. Even for the teams that are not having a single yes in the first hour, there could be 3 members are trying to solve different problems. So we've already seen that in the first place, the team just used CRT, took only 2 minutes to get their problem C passed judges test after submitting problem J. We could be seeing teams in the bottom. They get 3 or even 4 or 5 problems accepted in a very short time. But of course, they will be trading with the penalties. Okay, I think Wee is ready to explain problem J for us?
Okay, we have a short statement now, and this is problem J. So we have a music app containing n songs, and the playlist is a permutation of 1 to n. So it plays the n songs in the order, and it will loop infinitely. So after play the last song, it will start to play the first song, and so on. It will loop infinitely. But we have a desired order of n songs, and this is another permutation, so it may be different from our playlist. To achieve this, we will press the skip button. So we may skip some songs in a playlist and determine the minimum number of times we need to press the skip button. And we are also given the modifications that will swap two elements for one of the permutations. Also, we may modify the playlist or our desired order. So in short words, we need the playlist is actually an infinitely long sequence, and we need to find a minimum prefix that contains our desired order as a subsequence. I think I misread the problem again because I don't know.
Maybe
The
a little bit
desired
of
order can be
misread.
modified. Let me check.
Maybe a little bit of misread
Or
in the problem that makes you think the problem is easy.
yeah. But it should be still easy because many teams solve it.
Yeah, it should be easy. Probably there are some keys that we're missing here because we got already more than 20 teams solve it within the first hour. It's now the 61 minutes into the contest, whereas 62nd minute now. Maybe. Okay, so
Oh, I know the solution.
yeah,
Oh,
maybe
that's quite
maybe
easy.
you will need to try to organize it, and we should change the screen to the first solved to the, I think it's problem F, right?
Yeah.
Is there problem F? Yeah, it's the problem F. For the team, problem F for the team Rinshan Solution from Keio University, Japan. Oh wait,
No,
sorry,
it's a 217.
it is not the team Rinshan Solution. Sorry, it is the team 217 from the University of Tokyo.
Yeah.
They were actually the first to solve by they beat the team Rinshan Solution from Keio University by 2 minutes. Yeah. So, well, despite having the first solve to the problem F, the team 217 is currently at 14th place with 3 problems solved. And right now we are seeing strong zero from National University of Singapore taking back the first place. They got their problem C and E passed at the 58 and 60 minutes mark. So, yeah. Anything can happen here, still. So Wiwi, are you ready for problem J again? Okay, then we will
I think I understand the correct statement now. And I think it's really easy. I can confidently say it's easier than H.
All right, then maybe we should start your solution.
Should we explain all the solutions? Or I think we should leave some problems to everyone as an exercise or for the judges.
But if it is
So,
easy
but I can
enough,
still
maybe-
simply
well,
explain.
yeah, maybe
I can explain it briefly.
Yeah.
So, the key point is that we can map our each song in our desired order to its position in the playlist, and the number, the answer is, or we say we play the playlist one time means we play the n songs, and two times means, twice means we play 1 to n and 1 to n twice. Okay, so I think everyone understands. So the number of times we should play the playlist is how many pairs of adjacent elements in our desired order is decreased. For example, if we now change the number in our desired order to its index in the playlist. So for example, if our desired order is 132, then there is a reverse pair in adjacent position. Like 132, the reverse position is 32. So after play the song 3, we must we have to play song 2. So we can only play this song in the next time of the playlist. So we just see how many number of adjacent elements are in reverse order, and it will be very easy to maintain as each time we only modify 2 positions in this order, and swapping 2 elements in a playlist means we change 2 numbers also means we change 2 numbers in our desired order. But I think the idea is simple after coming up with it, but it takes a short time to come up with this, that there is a simple condition. Okay, so that's all of my explanation. I think we can move to problem H. Okay, this is problem H. I think it looks very weird.
Wait. We can have our another host, Little Cube, to explain the problem H.
Okay.
He just told me that he's got a solution here.
Oh,
So maybe we should let Little Cube to take over.
oh, that's great. So let's welcome him.
Yeah. So currently coming into our live is our another host, Little Cube. He's also a regional contest winner from I think it was 2023 Asia Taoyuan regional contest.
Yeah, that's an interesting story though. But
Yeah.
I don't think that's the main thing of this content. So let's first start.
Let's just
Yeah.
dive in directly to problem H.
Yeah. So problem H is if you just look at the statement, it's like quite simple. It just says you have 2 types of operations, right? So the first one is you choose both are in the same idea. It's like you pick an index and let's say what? How do we use let's have the board already because it's more simple to explain it this way. Okay, so it says we're picking an index. How do I use it? So I pick an index AI, and then I can choose a prefix before all the AIs, and after all the AIs, and let's say it's going to replace each J. We replace AJ into 2 times AI minus AJ. So at first glance, that's like a quite strange operation, I'd say, because there's no real world intuition. You'll say, okay, let's just make AJ like this weird formula because it's so weird. But you can see like if you can see the title, it's called reflect sort. So the main goal of using these operations is I'm gonna make the array to be non-decreasing. That means each index should be like no greater than the next element. And I also want each entry to be positive. So if you're like really familiar with the online judges like Coversis or AdCoder, you probably will see the problem format like this a lot because it just gives you some sort of operation and see, oh, you have to minimize something under some constraint. So let's say, what does a reflect sort mean? So if I try to visualize the array, say the sample is giving me 6, 3, 5, 5, and 2. So let's say we have 6, 3 is like roughly half. It's 5. 3 is roughly the half. 5 is like that. 2 is like this. So what happens? What happens if I select this and operate on the prefix? So what happens is 6 is going to be what? It's 2 times 5 minus 6 is 4. So it's going to be this place. And 3 is going to be 2 times 5 minus 3. So it's going to be 7. So see, it becomes this. So a really cool thing is I find it's like the reflect sorts refers to if you think this is the baseline, then you're essentially reflecting every single element in the prefix or the suffix according to this. So what is this intuition going to give us is if we look at the adjacent difference, then we see an interesting fact is for any operation, we are always negating the adjacent difference. Let's say the sample says if we, let's just say the final array is going to be, what was that again? 4, 7, 5, 5, 2. So the adjacent difference between this is minus 3, right? So because plus 3, it's minus 2. It's plus 2, so it becomes minus 2. So that's a really interesting transformation. Like some of these problems requires a really cool transformation. I think that's more like a mathematics Olympiad style, because in mathematics Olympiad there's like certain, I don't know, it's like combinatorics problems. I don't actually participate in any real mathematics Olympiad. So and I think back in this year, my team has another member that has certain these math backgrounds. So I think it's like really, really natural for me and we to not solve this problem really quick, because it is like this style is not our. Is this a first blood? Okay, let's pause the solution first.
We got Which problem was it?
B from just use
CRT. So yeah, now that is I think it's the 7th different problems.
7th?
Yeah, it's 7th.
Yeah, 7th.
Yeah, that is the 7th.
This championship is like escalating like really quickly, because like the last one. The last one is like only like I don't know. I'm not quite sure, but
no, that's the 6th one. The 6th was problem F at 59 minutes. It's now only the 73rd minute.
And the first team is already at 5 problems.
The leader is now at 5.
Yeah.
So probably they will be working on the 2 problems that we got team solved, but they haven't.
Yeah, and I think just use CRT is at slightly better advantage because they have 3 round tries at problem E. Although that means a bigger penalty, but that probably means they already have something in the problem yet, and Strong Zero hasn't seen any submission from now.
Yeah, but maybe, well, just maybe that strong zero is trying to solve some problem, but it could be just that they have no summations yet.
Yeah, but a wrong answer probably means something really great, like just something a little bit off.
At least they have a primary solution or primary thoughts.
But it also could be like some disastrous case, like they are missing a really important part, and that will cost them a lot.
Yeah, because for a top team, it is rare to see 3 consecutive wrong answers.
Yeah, and they are already at a penalty of disadvantage.
Yeah,
so if that's a disaster, then I have to win strong zero by the number of problems solved.
Yeah, I think maybe we should just continue on the problem solving first.
Yeah.
And surely we will have our first judge come into the interview after this.
Okay.
Yeah.
Okay, let's finish this quickly. So, we are getting this intuition of you're flipping the adjacent differences. Okay, so the problem asks to minimize the possible value of the dashed element, but essentially you're going to figure out that you are always going to flip all negative adjacent differences, and these adjacent differences does not change. So essentially you're equivalent to minimizing any single element in the final array, because they have all the same fixed differences. Any of them, the array can only be shifted upwards or downwards. So that gives us intuition to why not just minimize the first element, because adjacent difference doesn't work for the first element because there's nothing to subtract with. So what happens for the first element? So back to this form, so we actually get 2ai minus aj, and that means we're going to add a lot of 2 what and minus that thing, right? So basically I'm thinking is now the main target is we are going to find what operations we're going to flip. So we're going to flip every single the adjacent difference to the correct one. Now we are going to shift the whole level down into the whole level to the bottom part. So as like we're going to minimize a1. So an interesting is if I choose two different positions and I flip this one, that one, this one, and that one by prefixes. I mean, because suffix does not touch the first index, but prefix will. So if I flip that by prefix, what's gonna happen is I'm going to get 4 times ai. Let's say this a and this b. 4 times a minus 4 times b, and plus or minus, I forget, like the first element, like that. So that gives me an intuition of, so it is just we are going to combine multiple operations and one add, one minus, one add, one minus, and we're going to get the first one as low as possible. So this turns into a simple problem of you're going to make what's the lowest possible the first value. So I think that is just an easy remaining part. I think maybe it's like I see many of teams like writing GCD. So I think so I realized like after observing this, it is probably just taking a GCD of let's say maybe adjacent differences, and you have to make it 4 times because the operation going back and forth is going to be like that, or not. I'm not quite sure about this part though, because it's a bit difficult for me to actually derive the right formula. But I think like the main idea of the problem is like you're going to do this transformation, and it's going to be really just a math job to figure out what kind of classical problem you're going to use at the first part. Yeah. So I think it's time to welcome the judge for the contest analysis.
Oh yeah, for sure.
Seeing strong zero submitting D is currently
but it's still pending.
Yeah.
So well, let's first welcome our first judge, and yeah. So maybe don't go away too soon, as you might need to help. The team Strong Zero got a first solution. Yes, on problem D. So they are now X6. Well, now we welcome our first judge into the interview. Um, yeah, we're trying to solve some technical issues here before we can start our interview. So, yep, so we got our first judge here, but I still don't know his name yet. The reason of this is not because being disrespectful, but because their identifications, names, everything are actually confidential to all people except the judging team. So maybe we should let our first judge to introduce himself now before we can start the interview. Yeah.
Okay. Yeah. My name is Pikatan Arya Bramajati. You can call me Pikatan. I'm one of the judge members in this Asia Pacific Championship. Yeah.
Yeah. So, where are you from? Because our contest is currently being held in Taoyuan in Taiwan, but
Right.
we know that you're not a Taiwanese.
Right.
We also know that the only thing we know about the judging team is we have a lot of members that are not Taiwanese.
That's true. Yeah. Because this is a Asia Pacific competition.
Yeah.
So we gather various judges from different countries in the Asia Pacific region.
Yeah.
And I myself is from Indonesia.
Indonesia?
Yeah, right. So, yeah, I'm one of the representatives from Indonesia in this judge team.
Oh, so the judge team basically, like, I mean, contains judges from all like every regionals that the Asia Pacific consists, or
I guess every significant region that has main contributors that we have many from different countries in this Asia Pacific
yeah.
region.
Yeah, that's great to hear. So that means we don't have any of the countries like maybe having like too many people in the judging team.
Right, right.
Yeah,
It
but
seems
instead
to
it's
be
like
fairly balanced. I
yeah,
guess.
very balanced for
Right.
for every regions. So maybe we can dive into our analysis for the contest right now. So currently we can see on our screen. Maybe we should make our V3 on top so we can see the statistics. Yeah, so we're trying to display the statistics in our bottom of the screen now. And well, so we can see that we got 8 different problems being solved by at least one of the 70 teams in our contest area. Is this expected, or well, we know that our first to solve appeared at the 7 or 8 minutes mark
Right.
for problem K. Is this expected from the judging team?
I guess like the easiest problem is actually isn't isn't concrete that it's K. It's
Yeah.
actually we expected it to either be J or K.
J or K?
Yeah, for the easiest problem. We were a bit split on that because like some judge members think J is easier and some judge members think K is easier.
Yeah.
But yeah, looking at the results, especially since J is actually the third solved problem, right? It was K
yeah.
and then H.
It was first K, then H appeared
H first,
Yeah,
and
H
then
first.
J.
Yeah, and then
So
J.
that maybe affects how contestants see the problems and the reading order of the problem. So yeah, so looking at K, I think the first solve was in 7 minutes, I think.
Yeah.
Around
the first solve
that,
to
yeah.
K was 7, and the
Uh,
second solve to the K was at 10.
It was kind of expected, especially seeing the skill floor of the skill ceiling of this people who qualify in this competition, right?
Yeah.
And K is, I guess, like it's not trivial, but it is relatively simple. So
Yeah.
for them to be able to solve that quickly is actually expected. Yeah.
Yeah, here in the host live streaming run, we got 3 hosts today, and one of the hosts was busy trying to set up some environments for us, but we have 2 hosts from the start of the contest, and we actually have 2 completely different approach to how to solve the problem K.
Oh.
Yeah, we had Wee and I myself. We used binary search.
Right.
Is that expected, or?
Actually, we do have 2 different solutions. One of them is binary search, and the
Yeah.
other one is just greedy brute force with some greedy logic.
Oh yeah,
So
I used greedy.
yeah. For me personally, I think the binary search solution is more intuitive to see that it's correct, I guess. Yeah.
Wow.
So yeah. Yeah, we expect them to find any of those in any amount of time. So yeah, I think both are fairly similar in difficulty, I think.
Okay, so how about the problem H and J?
Okay.
Is that expected?
So something interesting about H is that we were split. So if you look at the 4th most accepted problem is actually C, right?
yeah, it is C, 12 teams.
Actually, during the judge problem setting, we actually didn't know which one is easier, C or H.
C or H, really?
Right.
Wow.
We were actually split about that, and yeah, we were actually split about that. Actually, I think more people thought C was easier than H.
Wow,
Yeah.
that is really an interesting news, because the amount of teams that solve problem C and H is quite
Very different.
it's very
Very
different,
different,
and
right.
have a very very big gap here. Is
That's true.
39 versus 12.
Yeah, that's true. For me personally, I think H is easier, which also reflects this.
Yeah.
But I think J is easier than K. That's what I think.
Yeah.
I think J is easier than K. So yeah, I think one of the reason why H is more popular right now is because the problem description and the problem premise is very simple for
yeah,
problem H.
yeah.
And it's very appealing for people to just read the few sentences of the
Yeah.
short statement and then just think about it.
And
And it's even more simpler than than J, right?
Yeah.
The problem statement for
yeah,
H.
because it is about time displays where people can see every day and perhaps
Oh yeah, that's
every
problem
hour.
K. That's problem K.
Yeah, that's problem K.
For problem H, it's just like array and operation, so it's like
Oh,
very
yeah.
simple. Like even compared to J, there are like some different days and stuff, and even more complicated with problem C. Problem C is you have like a pseudocode, and then you have to right? Yeah.
Pseudocode? Sorry, I haven't read the problem statements yet.
Oh
but,
yeah.
What does the pseudocode do? Do we like simulate them or?
For problem C, the premise of the problem is there is something about pseudocode, and then you have to figure out something about that. So
Yeah.
the problem premise itself is a bit complicated.
Yeah.
Yeah.
So it is just the statements is complicated, but actually it is easy. The problem
Relatively easy.
relatively.
It is still it does still need some few thinkings. And I think C is still harder than H, but I think it's
Not that
relatively easy. Relatively easy compared to the others. That's why it has a few solves
Yeah.
right now, right?
Yeah.
Yeah.
And as we're talking now, we're seeing problem E have 16 getting accepted. It seems to be the fifth easiest problem, at least for now. Is that also expected?
Okay, so if you're gonna look at the whole problem set, we expected J and K to be either one, the two easiest, right?
Yeah, too easy.
And then
maybe,
the next,
maybe the same level. Yeah.
right? And then the next tier is actually C and H are
Yeah.
fairly equal, which
Yeah.
is what we think. We'll see in the end if C will have similar solves to H or not, because currently there's still some disparity, and maybe that's just because people didn't have time to read C yet. So now that C is becoming a bit popular, maybe C will be at the similar number of solves than compared to H.
Yeah.
And then actually the next easiest ones after those four, we were actually not that sure about that if it's either D, E, or F. Actually.
D, E, F.
Right.
So these three problems are probably on the same tier.
Each judge member have different difficulty ordering for those three.
Yeah. Of course we know that different people would have
Different preferences and skill
Yeah,
sets,
yeah,
right?
yeah.
So we'll see. Currently, those three have similar enough number of solves. Maybe E is a bit more popular.
Yeah.
I guess that's because when was the first solve for E? I think it was very early.
For E it was at 35th minute.
Right.
Yeah.
So yeah, that was very early. So
Yeah.
people were start looking at that. I think the first solve for E was before C, right?
Yeah, it was before C, but
Yeah.
but not really that big of a gap.
Oh,
because
yeah.
The first to solve problem C was at 38th minutes, just 3 minutes later. So we can imagine when a team that first to solve problem C, it is actually Team Engen from Yonsei University, and the team first to solve problem E is HCMUS Taipei from Vietnam. They should be doing these two problems at the same time, almost the same time.
Oh,
we
yeah.
should say. Yeah.
Yeah. So yeah, but if we were to compare E and C,
Yeah.
I think they are not in the same difficulty. So I think E is significantly harder than C.
Significantly.
Yeah,
Not just a little bit,
not just a little bit,
but
like different. So they're stepping into a different tier of difficulty by going from C to E.
so we can say we got like if we're only categorizing the problems into, let's say, three different difficulties.
Yeah.
Of course, we know it is not just three, but let's say if it's only three, then it is C, H, J, K to be the easiest
Right.
four problems, and then we come to the median
Oh yeah.
difficulty of
So
the whole
so if we're gonna section the problem set into easy, medium, and hard,
yeah.
going into problem E is going into the easier side of the medium,
Ah, yeah.
Yeah,
Easier
going into
side
the-
of medium.
a bit easier side of the medium section.
Yeah. So how many tiers did the judges expect to have for this whole province? Because we got 13 provinces.
13 problem. Yeah. We have some like a rough partitioning of like easy, medium, and hard, but we also like to see it as a continuous spectrum of how the problem gets easy, then keeps harder, slightly harder every time. So we try to make that spread out. But for each section, for example, like the medium section, we don't really have to make it like linear, as long as we have enough medium problems and each have like different topics. So maybe different teams might think those medium problems can get different difficulty orderings based on their skill set. So we also try to do that. Like, for example, the medium problems, we have similar difficulty medium problems, but different problem topics.
Different topics,
right.
Different areas.
And also for the hard problems, like on the peak side of the extreme side of the difficulty of the problem set, we also make sure that the hard problems, different topics for the hard problems. So that means it will have like different teams solving the hard problems, and also to make sure that it's not that easy to solve every single hard problem, because maybe some teams only are strong on some certain topics. So it's very important for a team to have like each of their member of their teams very good at different topics to cover as broad of a topic spectrum as possible to be able to have a chance at solving everything. So
based on what we just heard, I think we can maybe safely say that the judging team worked really, really hard to ensure that for every team with different strong areas, they do have some problems they can work on at any given time start in our contest, but also it is hard to solve all certain problems.
That's where we have to make sure that everyone gets a chance to, like, there is a problem that they can think of, like if maybe they have like a strong suit on some topics. And also we want to make sure that we evaluate the skill set. So we don't make the problem only evaluate the ranking of this certain topic. We have to evaluate the accumulation of the collective skill set of various topics. So it's more reflective. So we want to make it so that the scoreboard and the ranking is more reflective of the real skill set ordering of the teams and the performances. So that's our goal.
And also, if you have more of the strong areas, that you get more chances of being on the top, like let's say top step of the podium.
Yeah, that's true. It's not only about how you can be very, very good at one certain topic. It's very good at various topics to cover many different problems.
So do we have, like, let's say the hardest problems, not just one, but probably all of the problems that you categorize it in the highest?
Right.
That are they the world final level, or because we know that we are producing at least 12 teams to be the world finalists today.
That's true.
So do we try to challenge them with these world final level problems, or are the hardest problems actually still having a little bit of gap to the world final level?
Okay, so we roughly measure the difficulty of our problems based on what we think the contestants of this exact competition was going to be. So this is like a Asia Pacific Championship, and then we look at the demographics of the people, like, there are teams from this regional, there are teams who got this performance on this regional. And we also compare that from last year's problem set. Last year's Asia Pacific and also the 2024 Asia Pacific. So we kind of use those as like a guideline, like a soft guideline where we can like Okay, estimate. First, we estimate like what kind of difficulty problems, and we also compare how the last year's judge difficulty estimation
Yeah.
compared to the real difficulty. So we also like evaluate like how last year's judges were able to predict, how well were they able to predict the difficulty distribution.
Yeah.
And so because of that, we put in like fairly hard problems, like very hard problems on the hard side of the contest, and we also compare that to last year, where we also have many various hard problems and also from different topics. So because of that, because of the different topic aspect, most of our judge members who are familiar with the hard problems, everyone get different opinions on which one is the absolute hardest, because every judge member has different
Yeah.
skill sets, right? So
Yeah. Well, for provinces, I think it is not necessary to tell which specific problem is really the hardest. I mean, we can have a split decision on
Right.
which one is the hardest, but we also can just have, okay, these problems are a similar difficulty
Oh yeah,
for these teams to try and work on.
yeah.
But at the end of the contest, if you manage to solve more of the hard problems, let's say if we have 3,
Yeah.
then being able to solve one of these 3 or 2 of these 3 will decide who is the champion.
Yeah.
You don't really need to solve all 3,
Yeah, yeah.
but you need to be perform better than other teams, or at least, I mean, if we got like 2-3 teams solving only 1 or 2,
Right.
but on the same number,
Oh yeah, yeah,
then
yeah.
it is the speed.
Yeah, it is.
decide.
It is the speed.
It is
right.
the speed.
Yeah. So, wait. I'm gonna answer why it's significant for us to gauge the hardest problem is because, on the surface, a problem set difficulty. One of the factors that decide the entire problem set difficulty is the difficulty of the hardest problem, right?
Yeah.
That is like, kind of like the final ceiling of
Yeah.
conquering everything in the problem set.
Yeah.
So, but actually, it's also the number of hardest problem and also like the cumulative difficulty of everything.
Yeah.
So, if the hardest problem isn't that hard, but it's actually many different hardest problems,
Yeah.
it's also very hard to get a full score of everything.
Yeah.
So one of the things that we need when we decide on the hard problems is we have to be realistic. First, we have to be realistic that each problem has a chance to be solved.
Yeah.
Because if we just put a problem that is like very, very hard, like it takes 6 hours to solve, it's like just
Yeah.
a waste of problem, and it doesn't like measure anything of the contestants,
Yeah,
right?
yeah.
So, one, we have to do that, but we have to make sure that solving everything isn't easy.
Yeah.
So
Definitely.
yeah, so
It
we have
cannot be that easy.
Yeah.
Yeah.
my prediction is that each problem in here have a good chance to be solved by at least one team.
Yeah.
But the rank 1 will not solve everything.
So probably like 11 or 12 hours out of 13. For the
11 or
first place.
12.
Maybe.
We're actually split on that. actually.
Really?
Yeah.
So some of the judges say 11 and some of the judges say 12,
It actually ranges from
or maybe 10 or less.
9 to 12,
9 to 12. Wow,
But
that is a.
I think.
I think that is really a big range.
Yeah, but we actually don't know. But there is a non-zero chance that one team may be able to solve everything.
Yeah. Of course, we know that easier problems you can think you can consider it as guard of they are guarding the hard problems.
Oh,
You need
yeah,
to
yeah,
fought through them,
yeah.
and then you get a chance to
That's true.
do the hard problems. So
I guess you can technically just start solving the hard problems, but I guess
Yeah.
they kind of need to do the easy problems first
Yeah,
to be able to be on the
because
same
it's
level
not-
of
yeah.
everyone else.
yeah, each problem gets the same score. You
That's true.
don't get like for example, we know that on core forces rated contests, we may see like the easiest problem get, let's say, one portion of the points, and the hardest problem could get 5 portions of the points.
Oh.
There's different weight. But here in ICPC, each problem gets the same weight.
Everything gets the same.
So a problem requires you maybe like, let's say, 3 hours to solve it.
Yeah, but it's the
Counts as
same.
1 point. Well, we can say 1 point for
Yeah.
a solved problem. But a problem that requires you maybe, let's say, just 1 minute to read and 10 seconds to think, then you maybe probably take only like 20 seconds to code.
Yeah, but it's the same
Also
way.
counts as 1 point.
Yeah, that's why it's very wise to just do the easy ones out of the way first.
Yeah.
That's true. Yeah. So yeah, that's true that one of the easy medium problems, they still need to be there, but it acts as a barrier that teams have to put their energy into them first before tackling the hard problems.
Yeah.
When they only have the hard problems left, they don't have the full 5 hours left, right?
Yeah.
So
Usually they could only have like maybe 2 hours there.
that's true. So that's why they need to allocate their remaining time on which problems they want to do and what is like the target amount of problems they want to do. And like,
Yeah,
That's true.
just when we're talking, we are saying like the team Strong Zero got the first to solve on problem I. Is that expected?
Let's
because
go.
now the team Strong Zero has 7 solved, but we actually have I think it's 9 out of 13 problems have at least one team.
Okay. So it's already. So the number of unsolved problems
It's only
is
4.
only
now.
4, which is A, G,
L and M.
L, and M.
Yeah,
And then I is the 5th to last problem to get solved.
yeah.
Actually, I think that is expected.
It's expected.
Yeah.
We still have like more than 3 hours left.
Oh, more than 3 hours left.
Yeah.
Okay. So the one who solved problem I is
Well, let's show the scoreboard on the screen now, so we can see
okay. Okay.
it is now 7-7, and then third place has only 5. It's two problems solved less.
So the team who solved I is the one who have the most solved right now.
Yeah, the most solved. And
Okay.
actually, the team Strong Zero, they are from National University of Singapore. They were, well, each of the teams can participate in at most 2 regional contests before
Right,
the championship.
right.
They had both their appearances this year
Okay.
winners.
Oh, okay.
Yeah,
So they're very strong.
it's 2 out of 2 for them.
Okay.
Yeah.
Okay.
They really are. I think we can maybe say they are the best teams.
Okay. Interesting.
Yeah.
Yeah. So it is one piece of information that the first team who solved I is the one with the most solves.
Yeah.
That means they have to solve everything first before solving I.
Yeah.
So it's different from, for example, the team who's first solved E.
Yeah.
I think that was their first solve, right?
Yeah.
It was the first one who solved E when everyone else already solved 3 problems.
Yeah.
So that kind of explains why E got solved very early. But for this one, it is solved by the person who also spent many time on the other problems. So
Yeah.
yeah.
Yeah. So now on the screen we're seeing a special balloon for first to solve. So Strong Zero got 3 different problems which are D, H, and I
Oh,
as the first to solve
D,
amongst
I,
all the
H.
teams.
Okay.
Yeah. So H was the easier problem.
Right.
And D, I guess, is categorized in median, right?
Yeah, D is not easy.
D is not easy.
Yeah, D is.
Definitely.
Yeah.
And I also in the median category?
Okay.
Let's say
So
if it's the whole spectrum, not just easy, median, and hard.
I think the judges think I is already in the easier side of the hard category.
Easier. So currently we got like so okay, so maybe I is just not being recognized by other teams.
No, it's the easier side of the hard category.
Yeah.
The
Sorry. I mistakenly heard.
Yeah. So
Yeah, easier.
we
side
think
hard.
I is harder than all of B, D, E, F.
Okay, B, D, E, F. Yeah, so
So
now
it
we
makes
know.
sense
Yeah.
how I is solved after B, D, E, F.
Yeah.
Yeah. But it makes sense how I is the first of the hard problems to get solved. Yeah.
Okay, so we know that JK are the easiest, and then CH, and then DEF, then problem B, right?
Right.
So now we know I is on the easy side of the hard problems. That
That's
means
true.
we got 5 different hard problems. Is that correct? Because we know
I
that
guess you could say that.
AGLM.
I guess you can say that.
Yeah.
I guess.
So maybe we can have a simple analysis on AGLM.
Simple analysis on like what makes them different and what makes them hard.
Yeah.
Okay. So, A is actually an interactive problem.
Interactive.
Yeah.
So it is not just you read a set of input and then output
That's true.
a set of.
You have to interact with the judge program.
Oh wow!
Yeah.
What the next output should be, or the next input you should read, is based on the previous output you give the judge.
That's true. So what makes interactive problem unique? You have to like create a strategy. You don't only make a algorithm that inputs outputs. You have to make a strategy on how you interact with the judge, and it makes like a different type of problem, which is very different from every other problem. So it adds to the diversity of the problem topic. So yeah, A is the hard problem that tests how creative someone is on creating strategies. Yeah.
Previously, we've seen this type of problems in we know Google Code Jam, but it is discontinued in 2022. But every year we can see 1 or 2 interactive problems in that contest. So, but we also know that type of the problems are the least solved by the contestants in the contest.
Yeah, because it's not that interactive problems are harder. It's just it's different.
Yeah, it's different.
Yeah, that's true.
Because there are we can say there is a lot of differences between let's say it's more like you ask a set of problems one time to another person, and they he or she will give you all of the answers at once, and then or it's like just we're chatting. I ask problems, and then you will answer. That might be the first problem's case, and then the next problems on how the chat will go based on what the responses are. And is it possible that the contestants tell that at a certain point they immediately know that it is not possible for them to get the program accepted, or they just have to try, or they just have to come up with a absolute correct expected solution from the judges?
Wait, this is for problem A? Or?
Yeah, for problem A, because we know that some of the problems there are a lot of different approaches.
Right.
But for this kind of
interactive
problem, or let's say specific on problem A.
Oh, I guess for problem A, the type of interaction and what the contestant is trying to do is that the judge program has a hidden information that the participant need to find a certain property of the hidden information, and they can do that by asking questions to the judge program. So it's like back and forth. The contestant asks something, the judge gives the contestant the information about that question, and then several times, and then within a certain number of questions and answers, the contestant has to figure out the hidden property of the hidden information. So that is what problem A is trying to do. So yeah, the contestant needs to be sure that the hidden property is correct. Yeah.
So we know that this kind of interactive problems, the back and forth are generated by the contestant's program will output something,
Right.
and then the judge's program will read it and try to process it and then respond something. So
That's true.
And then the contestant's program will do the same. But
That's true.
this kind of inputs outputs consumes actually consumes a lot of time.
Oh, yeah, because of like the input output runtime. Yeah, that's true.
Yeah, because for a program to get accepted, it is not just you have the correct thoughts, but also you need to be able to finish the program, terminate the program with a correct result.
Oh, that's true.
Or an acceptable result under a certain amount of time.
Yeah. So the thing about interactive problem, we want to make sure that the focus that we measure from the contestant program is the correctness of the interaction and the creativity of the strategy that they use, that within the number of questions required. So we don't want to make the input output runtime be an issue for the contestants. So usually for this type of problem where input output might be very slow, we make the constraint very small. So the constraint is small enough to still be able to measure the number of questions and stuff like that, but it won't affect like the runtime. The runtime should not be an issue. It's purely for the correctness of the strategy. Yeah.
Oh yeah. So it is all about the strategy, but we're not constraining the let's say how long you have to process it.
Yeah.
It's all about you need to figure out what is the most efficient question
Right.
to the judges to get the information you really needed.
That's true. Yeah.
Wow, that's really is interesting.
Yeah.
So yeah, we know we got interactive problems in this championship.
Yeah.
Is it the only interactive problems, or do we have?
It is
More.
the only one.
It is the
It
only
is the
one.
only one, and it is a hard interactive problem.
It is hard
Yeah.
interactive problem. Okay, so is it hardest on the hard side or the harder ones? Let's say, maybe not the hardest, but harder ones.
We're split on that. We're split. on
Okay,
that.
yeah. Okay, the judges are split on it.
Yeah.
So how about the other three?
The other three. Yeah.
Yeah, three. G,
maybe-
L, and M.
For L, actually, problem L is geometry.
Geometry.
Yeah.
Computational or
The problem premise is about geometry, and the solution involves some geometry, and it has a geometry. The question, what they're trying to ask, is about geometry. Yeah.
okay? So everything geometry in the problem.
Not everything, because it is not a standard, I guess.
Just involves a lot of maybe geometry algorithms, but it also can
Geometry is one of the aspects. It is one of the aspects.
just one of.
Yes, because if you look at the problem premise, the construction of the geometry, there is something else.
Maybe we should look at the problem statements. If-
I think there might be other judge members who can explain that problem better.
Okay, so we will have our so for today's contest, we not just have our first judge. We also, I think will have like 5-6 judges coming in, but they will be just trying to solve the problems live
Right.
instead of previously in regional contests or the championship or even the world finals. They just provide a solution video. Our
Oh.
judges will solve the problems live here.
Oh, okay.
Yeah.
Okay.
So okay, let's leave these problems to other judges.
Right. Okay.
And how about problem M?
Problem M. Problem M is actually about string,
String.
and it's specifically a special kind of string, which is a bracket sequence.
Bracket sequence?
Yeah.
So we're saying like parentheses, brackets.
Yeah.
And
Parenthesis sequence.
yeah.
So the problem is something about that, and it's actually a very hard. It's one of those type of problems where wrapping your head around the first premise of the problem is still hard, and then what you need to find initial observations to be able to, yeah, it is. I think it's a hard problem.
Okay. So yeah, we're still not seeing any team trying problem A or M, but
And
we
G?
do see a team trying problem G.
Oh,
and that is
right.
a regional winner. Just use CRT from Seoul National University. Well, they are the only representative from for the Seoul National University, so they already got a ticket to the World Finals.
Oh, okay.
They are safe even before the contest begins today, but well, they definitely will want to compete for the championship.
Oh, right.
Yeah.
Yeah.
So well, just as we're talking now, the team Strong Zero solved problem F.
Oh, wow. Okay.
For-
So
for
how
the
many
eight.
problems total?
They got 8 now.
8 problem. Okay.
Out of we have 9 distinctive problems.
That's
solved.
very interesting.
Yeah.
That's very
10 attempt problems and 9 solved by any of the teams, and our leader have 8.
okay. And this is like the beginning of the beginning after 2 hours, right?
Yeah, beginning after 2 hours mark. So 8-7-7 in the front. Well, Strong Zero and Just Use CRT are regional winners, but Fox's Q from KIST, they are not regional winners.
Oh, yeah.
And then we have STD-ABS for National Taiwan University, and in the 6th place, PC Komachi. Sorry, I'm not trying to dismiss Diamond in the 5th place, but STD-ABS and PC Komachi, they both are regional winners, and they both from National Taiwan University. So they're going 1-on-1 against each other.
Oh, this is like the determine their spots.
Who gets
Yeah.
the spot?
That's
because
interesting.
we know that since they are regional winners, National Taiwan University have already secured a ticket to the World Finals, but
Right.
only one of the 2 teams
Right, that's
can
true.
be the one.
That's true.
So they're going 1-on-1. They're both at 6. Well, so I think that is the whole of the problem set analysis.
Yeah.
From our first judge.
Yeah. Okay.
I think if I remember correctly, is Pikatan.
Pikatan, right?
Pikatan
Yeah.
from Indonesia.
Indonesia.
Yeah. So do you have any more comments on how the scoreboard looks right now? Let's say.
Looking at this, like previously before the contest starts, for me personally, I am very confident of the quality of our problem set and how they're able to measure the performances and how they're not like impossible problems or they're not too easy. And looking at this, now that the first solver, Rank 1 has 8 solves.
Yeah.
I'm still quite optimistic about our problem set. Yeah.
So it sounds like it's a little bit unexpected that there will be a team solving a problem within 2 hours. Maybe 6 or 7 was the expectation.
I haven't really like thought about like the details of like at the 2 hour mark how many
How
solves.
many
Yeah,
should
yeah,
we
yeah.
solve?
If I think, so 3 hours left,
Yeah, 3
and
hours.
they have
5 to
5
go.
problems to go.
Yeah.
Yeah. The chance of solving everything is still non-zero, of course,
Yeah.
but I don't think it's easy.
Yeah, it's
Yeah,
not easy.
it's not
Definitely.
easy. Yeah.
Well, in terms of the championship, they are now leading by 1 problem, or we can maybe say 2 problems, because currently 8 to 7, we're already 2 hours into the contest. So any problem being solved adds at least 120 to your total time penalty.
Oh, I
So
guess.
any of the so we can see that every team adding that 120 to their penalty exceeds the current penalties from their half. So we can actually say, although it seems like 8 to 7 between the first 2, but actually it is 2 problems difference.
Because of the penalty.
Yeah, because of the penalty for in terms of championship. But
I guess.
if we're saying in terms of the ticket to World Finals, they are actually 8 to 5. Their only opponent is currently in 8th place, Penguin and Tonic.
Oh, interesting. That's very
8 to 5. So that is actually a 4 problem lead, because
Yeah.
even Penguin and Tonic solve 3 right now, their penalty is still higher.
That's true.
Yeah,
That's
so
true.
it's yeah.
Yeah.
So I think that is really interesting.
Very interesting.
Yeah. So I think we should not take too much time
Okay.
with Pekatan.
Yeah.
Because I think the interview is already gone probably like 40 or 15 minutes.
Oh, okay.
It was supposed to go on with only 15 or 20 minutes, but
Okay.
we,
Okay.
we didn't expect that we can
Okay.
get so much out of our
Yeah.
first judge,
Yeah.
Pekatan.
Okay.
So, well, thanks a lot.
Okay.
I really don't know how to express the appreciation.
Oh.
Yeah, it's just so much, and yeah, so
Oh,
happy
yeah,
to
yeah.
have you here.
Oh, thank you. Thank you too.
For so much of time.
Oh, yeah.
So
Okay.
I think maybe we should take a short break after this, and then we will have another judge here to solve the other easier problems.
Okay.
Yeah. So thank you for your
Oh,
time.
yeah.
Uh,
Thank you too.
Yeah.
Oh, yeah.
Yeah.
Okay.
Okay, so now we are back to our streams, and I think we have talked enough about problems. So I think, first I think we are gonna. I want to see. Let me configure it. Yeah, now, Strong Zero is the leading team now, and they have a wrong submission on B. But interestingly, they are solving problem G. And from the judge note, they say that the judge UCRT team's solution to G seems correct, but there are like some details missing. Like, what do you think about they are not solving B, and it's like it's over a half hour after they have submitted B.
Maybe they have printed their solution and they are checking their code on papers, but they still did not discover their mistake.
Oh yeah, that could be it. That's really interesting because that's over half an hour, and I wonder. The worst case of that is their solution to B might be completely incorrect, but we cannot see it because we don't have the camera, right? Yeah.
Oh, maybe they want us first spot for problem G.
Oh
so
yeah.
They write G first.
Yeah, they are already leading a scoreboard by a lot. They can just play for
And
first.
Penguin and Tonic solve how many problems? Oh.
5 problems with 295 penalties.
Oh, Strong Zero solve 3 more problems than they.
Yeah, so they don't have the pressure. I
Yeah.
mean, they do have the champion pressure because
Oh,
you get an extra title in the World Finals. Yeah, we can look at
but they may think the first spot is more important now.
we can look at Strong Zero versus Penguin and Tonic. Let's see. Let me hide this one and show the PvP screen. So Penguin and Tonic is solving problem F, right? So F is just like a standard problem. It should not be difficult for any of the top teams. It's just a matter of time whether you're going to use the correct referenced algorithm in your codebook, also known as the team reference document. Yeah.
I
So what are
saw.
they
I
doing?
see they are writing NTT.
Yeah, they're doing numeric number theory transforms. Yeah, this is a like really relatively simple problem. Yeah, so they have a lot to do if they want to win off Strong Zero. Yeah, so that's back to the scoreboard, and we are going to see some interesting pictures from the judges' team. So the main thing about this contest is not just about who wins, who gets which plays. It's also about some of the behind the scenes things. Okay, so first we have some. I'm not sure if that's appropriate. Okay, so we're gonna show this one first. So apparently the judge saw the team NU and the Chaos has some non-conventional function naming. So I mean, it did occur to me that in one of the World Final streams, there's a team like they probably got really pissed to solve one of the problems and add the function called that, and I saw the other team doing the same because this is a lambda function, right? This is not. Why are they asserting? I mean, maybe they are really pissed, so they got like really paranoid to add these assertions. Okay, so we also have another one is the problem E. Do you know problem E?
Oh yeah, I read problem E. Spend all their time together to solve on problem E. Looks like they finally remember to compute partial sums.
Oh, so
Oh,
is it E or F? I'm not sure. No, it's probably E because it's all.
I think this is problem E.
Yeah, it's problem E. So they do need to compute partial sums. They didn't. So why did they actually got their sample correct? Because if they spend the wrong answer on the samples, that's gonna be really costly, and I think every single team competing for a top slot is gonna avoid that. Yeah, I don't think this looks like it will pass the sample. Well, it's like, what's the output of problem E? That's E.
I think this is not the output. They just not just doing some preprocessing for the input array.
Yeah, but if you didn't do that, that's not gonna be correct. or maybe it happens to be correct. That's gonna cost them some time. Yeah.
I think it's reasonable because I think this will be wrong only if m is much smaller than n.
Oh, so
So only one sample input maybe.
yeah, there's only one sample, and the n is 8 and m is 4, right?
Mm.
Yeah, so that will be basically adding pairs of integers. Also, they probably accidentally got the sample correct. That's not the teams will won. Okay, the last one we got it from the judge for now is about. It's a game about just use CRT, and it's the oldest trick in the book. It's like you got overflow, so you define int to long. Yeah.
Oh, that's a bad practice.
Yeah, that's a really bad practice because long is like twice as huge as int, right? In terms of memory, and it's also going to cost you the runtime because adding 64 bits integers is gonna be slower. Yeah, so, but it's like the oldest trick in the book. Like you find out like, oh, I got overflow. I just do define int long and submit it again. It probably will pass.
Yeah.
So that's most of that about now, and we're seeing just use CRT also submit. When did it submit a wrong solution to D? Let me see the scoreboard. I can't see from the scoreboard. Let's see the. I'll take a look at the queue. They submitted at roughly 4 minutes before, so it seems like they are probably. Let's see their screens. What? Team view. Just use CRT. So they are coding problem D. So they probably already found what's wrong about problem D and about problem. What's that? Problem G. They probably just printed it out and they are figuring what's wrong with it. So they used HLD. It seems like that, and they use I haven't read the problem D, but it's okay. Just thinking, just watching them.
Guess what they are doing?
Yeah. Print. I see in terminal they did print file i.cpp. And wait, they are they're writing main without I.
Also, they are solving 3 problems
They're
at the same time.
They're solving 3 problems at a time.
Oh, we sometimes do that. So
yeah, I think that's a absolutely valid team strategy because you got 3 people, and sometimes it's better to not just stuck on the problem because you might just make some mistake that's not gonna be found out like in a short time, and maybe that if you stuck on the problem, maybe that's gonna cost you the whole contest. So they are doing 3 problems at once. So we might see them.
solve all 3 problems at the same time.
They will win off Strong Zero by 1 problem, 2 problems. But Strong Zero is also solving problem G. So it's hard to say who will win at the end. This is really intense battle between the 2 teams. They got a lot of warning. They use scanf. Scanf always warns you for that. Is that from like some macro or something like in the VS Code? Like they have like a really long, and why are naming their solution folder is called Daniel 1 solve. Oh, they're submitting.
Oh,
Problem D.
nervous.
Let's see what the screen might be like a few seconds delay. So let's look at the queue. The D is running. They got time limit in a really early test case. That's not good for them. Will they figure it out really quickly? Oh, they're just gonna print G. What? They didn't print G. Oh, they're printing both files. So they probably did some debugging on the G on the PC before we have looked at their screen, and now they are printing 3 files, G and D, G, and I, right? Okay. So they're typing the input. Is that the sample input from? What's that for? Maybe D. Yeah, it looks. It doesn't look quite like the sample input of D. Is it?
So they don't need to type the sample input by themselves because they can copy it.
Oh yeah, they can copy in the PDF.
Yeah.
So that probably is some counter case they found previously. So they're debugging G. Is it a G sample? So they decide to type in. No, G sample looks so different. So it's not that. So what team should we look at now? Do you have like a good suggestion?
Mm, who is in the third place? Maybe we can see Fox is cute.
Yeah, let's take a look at Fox is cute. Fox is cute. Okay. Now they are solving problem I. They're hard coding. They're typing a lot of 2 times 10 to the 5th in the code. You should probably just use a constant if you're gonna use that a lot. Wait, what are they doing? Oh,
What's this?
they're writing a brute force solution. So I it's a problem that basically does a simple counting.
Yeah.
So they're writing a brute force that. Oh, they're
This is
probably
finding vectors of numbers.
yeah, they're probably just estimating some of the brute force part of.
Oh yeah, this is the brute force approach.
Yeah, because there's a like in how should I put it in problem I is like a problem related to factors of number. So in these problems you usually do some brute force, and it's better to just run a machine to test if it will squeeze it into the time limit or not. But that seems to be all of them. They are not doing anything else. And they also don't have how many files are there? B, C, E, F, H, I, J, K. So I is the only problem they're solving now. So they are probably thinking about how to do that. So there's no progress currently. What about, let's see, maybe see the National Taiwan University's team. Let me put them on the screen. Wait. Their team photo is not showing. Oh, because I need to do that again. Okay. Team photo. Oh, no. Wait. Okay, let's see. Is it on or not? Yeah, the
Oh.
is PC Convention is looking at Scoreboard. And SDABS is currently writing problem I. They have is it I? Yeah, they have really long code
So many
going
ties.
on. Yeah, something like that's like.
That's why we see
149.
is 140.
Yeah, but
There are more.
the main star has 62 line, so they're like the default code's probably gonna be very long, like around 50 lines.
But I remember that their default code is not so long, so
Yeah. Huh.
there may be some data structure above the main function.
Oh yeah, that could be a case. So what does it look like? They are writing. I don't know. I haven't read. Is problem I? Oh, that's problem I. So I did read that. They're pre-computing something because you see the C in N is at the bottom of line 140.
Oh yeah.
The preprocessing
So,
is
so their process is
is it intended?
over 70 lines long.
Yeah, is it intended for the problem or I'm not sure. I didn't. Maybe like later we will figure out when maybe there will be judges solving this problem. Yeah, so we can also like let's take a look at the fifth place. Daimonji was from Kyoto University. Let's go back to the single view. Oh, wait. It's the... Okay, so they are using sea lion. That's quite rare in the regional context. Like I think it's like mostly in Asia Pacific. People often use like a Vim or VS Code, and it's quite uncommon to see sea lion in the contest. They are solving I. They have already like created all the problems until O. I think that's because in order to not let the participant know how many problems are there, in the contest venue before the contest started, there was like 15 different colors of balloon. So they assume that there will be until problem O, but that's not the case. Yeah, so they only have the directory to problem M, which is correct for 13 problems. So they are also approaching problem I. So basically, most of the top teams are doing problem I for now, except for like PC Komachi didn't have any problem solving any problem right now, and just UCRT is trying to solve 3 problems at once. Yeah. Is that also a pre-computation? Like, they also didn't input N in the code currently I'm seeing. Oh, they're probably just counting some things, right? Okay, so that looks like I is a relatively complex problem. Yeah.
They also have many lines.
Yeah, there's a 140 40 line. Whoa, that's
Oh, their main function is from 65 lines.
65. So that's roughly the same length with the STDABS team, right? Okay, add another. Okay, so we have a message from the judges. Let's show it on the screen, shall we? Yeah. Okay. Okay. Oh, this is so large. Okay. So in Don't Judge, like virtually in every single ICPC contest, if you got wrong answer or sample test case, it's still gonna count as a wrong answer. Is that same for code versus gyms? I think it's like maybe up to the contest configuration, right?
I'm not sure. I never see like there is an option related to this, but in my experience, it is not counted into the penalties for wrong answer on test 1, but only sample test 1. If there are multiple sample tests, then after the sample test 1, you will get penalties.
Oh, so you're still
Maybe.
gonna have penalties if there are like 2 samples.
I hope I'm not wrong.
Yeah.
I'm not sure.
But I think if it is like a regular contest, it's like for example like our online mirror in the also is that a universal thing? Like it just doesn't count at the first sample test.
Not sure.
Yeah, but yeah, maybe. but like they forgot to comment out their error dumping. It seems like that. So they used C out for errors. But if they use CER for the errors, they probably will get a time limit because the error stream is quite slow. You will flush every single time when you're for every single line you output in the error. Is it every single? Oh no! It's every single thing you output in the error. You'll flush immediately. So that will be a lot of things going on in your code, and you're definitely getting time limit unless the overall output is like relatively small, right? Yeah. So back to that, they are running and they got wrong answer. They have a it seems like they have a whole testing script, right? So like automatically test a sample test case. That's really smart. Yeah, but they are just testing, so it's definitely gonna get wrong answer on the first input. Yeah. Oh, but that will get a bit complicated because it seems like from terminal they are using diff, and if like for like constructive problems where there are several different solutions, the output's gonna be really weird. So I want to disable the photo because I want to see what kind of achievement the team has. Let's just re-display the team back. So they have a really big gap between problem C and F, but they solved 2. They got like really high place in the regionals, right? So number 4 and Yokohama number 3, and these are the harder regionals in the Asia Pacific region, right?
Yeah.
Yeah. So are there like new solutions for the top teams? HCMU's Thai family just got another solution to B, so they are in the 4th place. That's back to the scoreboard. Alright, the score is already on. I just need to.
Oh, it's on.
Yeah. So HCMU's Thai family just got B solution, so they are now in the 4th place with 619 penalties. No, like CABS are having like really low penalty. They only have 1 incorrect submissions. That's the same for Strong Zero unless they decide to pick up B and solve it. That will definitely be at least 2 wrong submissions, but they are already ahead in the contest, so that's not gonna matter for them. Yeah. So what about our teams? HCMU's Thai family got like relatively larger penalties. Like 619 is the largest among the top 7 teams. But that probably doesn't matter because HCMUS is so ahead in the championship. It's if they can keep this up, they will definitely get a ticket to the World Finals. So unless they're aiming for a higher prize, that's not gonna matter for them. But yeah, there are so many regional champions. So they're actually the second. They're actually the second team in the scoreboard competing for the World Finals seats, and Daimonji is also almost guaranteed if they can keep up this kind of performance. So we have our Penguin Tonic, now in rank 7, they have all of the solved problem by them. Doesn't have a wrong solution except for C. If they are definitely going to have C solved, right? Because missing a problem that virtually like everyone in the top 20 has solved is going to cost them like one problem, and missing one problem, that's an immediate lose. Even you have like a really clean scoreboard or a really clean penalty. So see,
SDF is submitted I.
Let's see. Let's see their screen. Let's just see their big screen. What are they doing? They're
writing E.
They're writing E. They just don't care.
They don't care.
They just submit the problem and they's like, oh, I'm going to get accepted. It's just a matter of
I think they are
time.
going to get accepted.
Yeah, they're going to get that correct. That will be the second solve of problem I. That is their confidence about their code. They're just going to submit, and going back to C, they already got it correct. So now they are back to rank 4, and they are just one problem behind Strong Zero. Strong Zero hasn't hasn't submitted any single solution, any single code in a long period of time. Okay, so what is Strong Zero doing? Okay, let's see. Okay, well, for now, I think we can also look at other teams. So I'm gonna replace the team view into an auto mode. So it will start to cycle through different teams now, I think. Is it not working? I think it should maybe have the scoreboard hidden. No? Let me figure it out. What's wrong about? Let me look about it. Camera and so let's hide the scoreboard. So it seems like some of the screens didn't come out, but we can still look at different teams. So from Green Solution from is like the KO University. Yes, they are the second place in Yokohama Regional, and they have 6 problems solved. They're probably having a hard time because the problem E has 5 incorrect submissions. So it's going to matter if they can sustain this kind of mistake and keep going on a contest. Is it not? Oh, I think I misconfigured the screen, so I am going to re-enable that. Yeah. Okay, so PC Komachi is now starting to have a solution for problem. What is this? Problem D. So they're writing something. They're writing a node. So I suppose that probably is about tree or segment tree. Now back to Penguin Tonic. They haven't touched their computer, or they are doing some testing in problem C. So they probably couldn't figure out what's wrong about their solution. Do they have like other problems going on? No, they are probably going for C because the scoreboard effect is going to be really, really crazy. Like if in a contest you're having a problem, you got a wrong answer, but it's solved by like crazily many teams and counting. That's going to make you be really, really nervous. Like, do I stop and get this problem correct, or I just ignore it and just keep going on? So like both strategy exist, but I think if it's me, I will probably just go on if I have that kind of mentality still remaining, that kind of mental capacity. And now seeing here for the free snacks, actually getting 5 problems all in one attempt, and they are actually a really strong team because they are really high ranking on the regionals. So they are solving problem D, and I'm seeing like a really similar thing from the team PC Kamachi. They are defining some kind of info to store on the data structure, and this is the 5th place. Now they don't have anything going on. They're just looking at a scoreboard. So what are left for these teams, like problem D and I, right? So they probably are solving them, but we cannot see because we don't have the camera. Well, there's nothing going on their screen. And for the University Tokyo team 217, they got wrong on E. They have 2 solutions in E, like they're E1 and E.cpp and E2.cpp. So, wow, that's what they are using. Rollback Mohs algorithm. They got that seems like a whole template. I'm not sure. Is that true for the problem? We didn't know that. Well, let's leave it to the judges. And for this is the SSQS, another team too. Oh, they are in 7th place now. Because they got B correct in 2 tries. Now they are working on problem D. They could have a really, really fun place in this championship if they actually got this correctly. Now for back to this, this is another team from the HCMUS. So they are solving E. It seems like that. So like, I think the current situation for most team, except for Strong Zero and just use your T pass problem D. Is it? I just missed it. So except for the top 2 teams, there are still at least 2 problems remaining, which is problem D and problem I, and they are probably also missing other problems. So for the teams that are not the top 2, they are probably just trying to keep up with the scoreboard. So most of the teams are just picking like what's the remaining problem for them and solve the easy one or solve the earliest one they have figured it out. So this is I think this is quite different from the past World Finals, because sometimes in World Finals the top team is going really slow, like in like now it's almost 3 hours mark. It's almost 3 hours mark. In World Finals, sometimes the top team go like really slow. So because the problems are significantly harder, and I think personally, I think past World Final problems have some implementation flavor. So even you can solve it quick, you can figure the solution quick. You are not going to code it quick because the problem is maybe intended to be difficult in both aspects. Now, Stormzero haven't got any single solution, and it's going to be in almost an hour. Now, this is a uniformly random name from University of Melbourne. They are getting problem F. Yeah, so most of the team are just following the scoreboard. Let's see if we can like find some really, really interesting things going on these teams. They are opening another. That's back to. This is Cartesian tree 2 from National Young Childhood University. This is definitely problem F, right? They got the NTT going on their code. Their NTT is like really, really small. Oh, because it is just for the transform part. So if they need to do like polynomial multiplication, they have to write another function. That's, I believe. So now Miller is debugging. Their debugger message is okay here in triple question marks. So what is this problem? This is also F. So many teams are working on problem F. Yeah, problem F got a lot of solved, so they are probably going to pick that as their next problem. Now they have just submitted F, but they already got it correct. Did they know that? Because if you are using the terminal, I think they does know that because they're working on another problem, and in terminal you cannot. In the terminal you can submit, and that's going to be quite helpful because you probably just tested the sample test case. Yeah, they got this is another team. They just got F correct. Okay, so let's go back to. I'm not seeing like some interesting thing going on. Maybe because in dress rehearsal, maybe that's like in dress rehearsal you're going to do a lot of weird things because you're going to test what the workstation is like. But in a real contest, you're not going to do some really really weird things because that's gonna cost you time, and most of the teams probably wouldn't have the time or the nerve to do that in the contest. And that has to be like randomly picked into this one. So I think for now we will probably let the stream going on for different teams, and we will try to invite other judges to discuss the solution of some of the problems. Okay, now welcome back to our live stream, and now we are invited the judge for the problem D and problem J. Now he's here to show some problem solving, the problem solving hints, or the full solution to the problem D. Yeah.
Yeah. Okay. Hello. My name is Albert. Although you can probably see that on screen. Some of you also may know me by my username. I'm more popular in that name. I'm Zenite. And I've been in the championship as a contestant for the past 2 years. And this time, I've been to the World Finals twice. So I started setting problems. And I'm the problem setter for problems D and J. Okay, so as you can see on the screen here, we have a brief statement for the problem. So here for problem D, I think right now we have a couple of solves already, right? So in the problem, we have a rooted tree with n vertices, and each vertex has like a value of AI. And we want to perform some operations on the tree, so we can choose one vertex, and then we remove, we decrease AI by 1 if it's still positive. So maybe I'll try and draw here. So here, let's say, is there the samples in here?
Samples, I can give you the
Oh yeah, the problem
problem
statement.
statement. Yeah.
Thank you. So in the problem we're given, let's say we have a tree here. Oops, this is not the correct tool, it seems. Okay, thank you. So we're given a rooted tree here. Let's say 1, 2, 3, 4, 5, 6. And then each vertex we have a value. Let's say we have this value is 5, 3, 2, 5, 2, and 4.
Yeah.
So what we are going to do, can I alt tab here? I'll just click this.
Yeah, you can all tab here. Yeah.
Okay.
It's fine.
So we are going to choose a vertex, and then we check its path to the root, and we're going to decrease AI by 1. So let's say we choose vertex 4, and then we can decrease all the AI by 1, making it 4, 2, and 4. Let's say we are going to do it again. So it becomes 3, 1, and 3. And if we do it again, it becomes 2, 0, and 2. If we choose vertex 4 again, it will be 1, 0, and 1, because we only decrease it when we still have a positive number of AI here. So using these kinds of operations, we want to know what is the minimum number of operations we need to make every value here equals 0. So we want everything to be 0 in the end. Of course, if we stop the problem there, then it would be not very interesting, right? So
Yeah.
to make the problem a little bit more challenging, okay, it seems like Alt tab failed because I have Chrome tab open somewhere. So to make the problem more challenging, of course, we have to make it a query update problem, right?
Yeah.
So we are going to make it so that you need to output the number of operations for the initial state of the tree, and then I'm giving you queue updates where I can modify the number of AI. I can modify the value of AI for one vertex, and then you have to output the new number of operations needed for making the entire tree 0 again.
Yeah.
Yeah, so of course, for these kinds of problems, we need to start by first solving the version without any updates.
Yeah.
So let's see. What can we do if there are no updates? All right. Because we were asked to do all this, then one observation we can make is, let's see. I want to clear this.
You can you can use the computer. I can do that.
Yeah.
I
Oops.
think click every.
Oh, just Control A then?
Yeah, I can just do that.
Thank you. So yeah. Let's see here. Oops, this is the wrong tool.
Yeah, I think you.
Yeah, the brush tool should be right. Okay.
Yeah, that's a brush tool. Yeah.
So let's say we want to decrease. So it was like 5, 3, 2, 4, 2, 5. Yeah. Let's say we want to. We have solved for this subtree. Let's say we solved that this subtree needs a total of 6 operations here, right?
Yeah.
So if we say we need 6 operations here, then let's say this was 15. Then if we finish this subtree, we have done 6 operations on this left subtree here. And because of that, as a side effect, this 15 vertex will have decreased its value by 6. So it now becomes 9. And let's say we solve this subtree. We need 5 operations here, and we have 4. So 4 left in this vertex, we can do an additional 4 operations to make it 0.
Yeah.
Yeah. So we solve it from the bottom to top. And of course, this leads into a DP on tree problem.
Yeah.
So let's say this is a vertex U. We can say that let's say DPU is the minimum. Oops. It's the number of operations we need to make that entire subtree equals 0.
Yeah.
Then we can say that the DPU is equal to max of AU, which happens when this is greater than all the operations we need in the children. Or we can say it's the sum of C child of U of DPC, which happens when this second case happens if we already have a lot of operations in the child, and then as a side effect, the value of AU on this vertex here is already 0.
Yeah.
Yeah. So this DP, hopefully it's quite simple, and you can implement this in all DP. You can implement this in ON.
Yeah.
Yeah. Now, what do we do if we have, let's say we modify a vertex, right? The value of AU. Of course, because this DP pulls up from the children's values, if we modify a vertex, then we have to modify all of its ancestors, the DP values of its ancestors, which if we do naively, if the tree is tall, then, well, we can probably need ON operations to update. So we see that, it seems like we have a path update here from the vertex that we update up to the root. Now, of course, when we have some problems about path update, then we can turn to data structure. We can decompose the tree using heavy light decomposition. We can do HLD here. Oops. Because we have path updates on the tree. So how do we manage these kinds of updates, right? So let's start thinking in terms of like HLD. Of course, we know like we decompose the tree into a bunch of chains.
Yeah.
Yeah. So how do we formulate the DP in terms of chains? Let's say we have. I'm going to use blue here. So we can differentiate the heavy edges and the light edges here.
So reds are the decomposed chains, and the problem is like the blue edge is going to be problematic, right?
Yeah, that's right. So these the red edges are the heavy edges. That's part of the chain. So this is one chain, and the blue edges are the light edges that separate the chains.
Yeah.
So if we already have these, then
That's
That's a big eraser. So let's say we want to find the dp value of this.
yeah.
What's dpu? Of course, dpu can be the maximum of au. Oops, that's the wrong tool again.
Yeah, it's a brush tool. Yeah.
dpu is the max of, it will be au, of course, and it will also be dp. Let's say this is the heavy child, right? Let's say this is hu, so it will be dp hu plus the sum of these, the sum of the dp of the light child. So let's say we keep a second array b that so b is the sum of the dp of the light child,
Yeah.
of the light children. So this would be bu. Now what's interesting is that in each chain the value of the dp, we can try to open up this formula. So let's say this was the topmost vertex.
Yeah.
Right. Let's say this is C1, C2, and C3. Well, maybe this is, we can make it this C0 as well. Yeah. So if we look at it like this, it will be dp C0 is equal to, that was the max of A of C0, right? A of C0. C0.
Yeah.
And then it would be like dp C1 plus BC1.
Yeah.
Sorry, BC0. But
BC0,
what is dpC1 here? dpC1 is, this is a maximum of AC1 and dp, so dpC1 itself is AC1 and dpC2 plus BC1, right?
Yeah.
So if we put that into the formula, we're going to have something like, this is AC1 plus BC0, and then we're going to have dpC2 plus BC1 plus BC0.
Yeah.
Yeah, if we go down, if we continue down the chain into the bottommost part, then we're going to have a form that looks like this. AC3 plus BC2 plus BC1 plus BC0.
Yeah.
Then AC4 and so on. And because we only need the topmost dp of each chain,
Yeah.
as it will be put into the b value of its parent, right? Or in the case of the root, then it will be the answer here. So we can, of course, if we update the a value here to get this maximum, we notice that there's one term for each value in the chain, correct? So we can just put these values in a segment tree. So the let's say index 0 stores AC0, index 1 stores AC1 plus BC0, index 2 stores AC2 plus BC1 plus BC0, and so on. And then to get dpC0, we just query the segment tree from the start of the chain until the end of the chain.
Yeah, that's just a whole segment tree.
Yeah. So then after you so when you update an a, right, the a value of AC2, for example, you update this index in the segment tree. You update index 2,
Yeah.
and then you update the value of dp of the, if we update here, then we update the segment tree and we update the dp value of the C0, that's the root of the chain. And let's say that that's not the root. Let's say there's something higher that has this as its light child. If this is P, then the value of BP will change.
Yeah.
And if the value of BP changes, we notice that a value of B occurs in the suffix of the entire chain, right? So
Yeah.
BC0 appears in all but the frontmost one, and BC1 appears in, like, starting from the third element and so on.
Yeah.
So we can just do a range update on the segment tree. So we can just make a segment tree with lazy propagation.
Yeah, so you need a segment tree that computes the maximum.
Yep.
And you will need a range update.
Yeah, that's
you don't
right.
need a single point, right? Because it's
Yeah.
single point is just special case of the range update.
Yes, that's right. So with that, because we know in HLD there's like log n segments up to the root,
Yeah.
and each time we log n chains, sorry, and each chain we just do one update or one query. So we have like log n per chain. So per query we can solve it in log squared n.
Yeah, so
Yeah.
that will be the preprocessing can be like in linear time, right?
Yes, that's
so
right.
it's n plus,
plus
q
q.
times log squared n.
Yeah,
Yeah.
that's right.
Like actually, like after I'm hearing the max, you can expand that. So
Mhm.
what immediately comes to mind is, if you can build a segment tree like with a composition, it's like each term is like maximum of something fixed, and an unknown value plus b, like given a and b. So we
Yeah.
have maximum f a and x plus b.
Mhm.
So we can always going to expand that into the same form. We are nesting to max because let's say just the first three. So
Yeah.
that will be AC0 and AC1 plus BC0 are known.
Yeah.
But AC2 will that will be DP U2. That will be the new unknown, and
Yeah.
the other constants are known.
Yeah.
But I think like implement list is actually more difficult and more complex, and the range update segment tree approach is like much cleaner. So if you actually got that one, you're going to write that real quick.
Yeah, that's
yeah,
right.
and solve it really, really clean.
Yeah. And I also noticed that, of course, this is one of the problems that is easier to solve in the mirror, of course. Yeah.
Yeah,
because
it's easier to because you can
because
just copy paste.
Yeah,
the
you can
segment
copy
tree.
paste the HLD and you can copy paste the
Yeah,
lazy sec tree in there.
Just copy paste everything and you got it correct.
Yeah. I think that's my solution. I'm not quite sure if the other judges have any alternate solutions, but it seems that some of them have shared to me that right now we're updating it from bottom up, right?
Yeah.
And like let's say you consider something from top to bottom, of course it would be quite hard because of the structure of the DP that computes from the subtrees first.
Yeah, I think like in terms of coming up a DP solution for without modifications, like bottom up is like quite straightforward because when you're top down, you're just looking at a vertex and you know the vertex ornaments, but you don't know like what operation am I supposed to pick in the subtree.
Yeah, that's right.
So that's a really interesting question. Do you think like is it like about the middle part of the problem set? Because I think even though the final solution is like reclaimed, like writing an HLD and the segment tree still costs some time because the participants have to write everything from like they have nothing to copy paste.
Yeah, that's right. I do think that maybe while the implementation can take quite some time, but I'm pretty sure that when I'm looking at the other problems, I see like some various problems that, let's say, B, for example, I can see the code is quite short.
Yeah.
But maybe you would need to think quite a bit harder to come up with that solution.
Yeah.
Right. So I think that while this problem has a hard implementation, it may be compensated by how many of the observations can be like reapplied from other problems. Like you've surely encountered many DP on tree problems before, and expanding the maximums to make sure that there are no DPs left in the chain as well.
Yeah. That's like a quite balanced design. Like if there are some problems with you're going to think very hard and come up with a really short code, and some problems are actually testing if you know these classic algorithms and able to combine them to solving these problems. That will be a really good test about the team strategy. Because if you don't split up the different tasks between the teammates, this is going to cost you so much time, and you will get a lot of penalties out of that.
That's right. And also, you also highlighted like it's very important to have a balanced skill set among all the team members, right?
Yeah.
So you can like delegate like this task to, let's say you have a participant who's really good at implementation.
Yeah.
You can just give it to them. And let's say you have I noticed there's some maybe graph problems. There are quite some graph problems here,
Yeah.
and there's a math DP problem as well. Maybe you can. Maybe there's one team member that you have that's really strong at those kinds of things, and you can just maybe you can ask them for if they have seen a similar problem before. Yeah, and that'll make it easier to solve it, right?
Yeah, that's true.
Yeah, and for problem J, you have discussed it already at the beginning
Yeah.
of the stream, so I don't think we really need to repeat it, as my solution is very similar to what you presented. It's just maybe the code is a little bit different, but the general idea is the same, and I think most of the participants also solved in the same way too.
Okay, so thank you for coming to the live stream for presenting the solutions. I really appreciate your presentation here. Yeah, that's really good.
Yeah, thank you. Thank you for having me as well here. Yeah, hopefully we still have a little bit of time till the end of the contest, and hopefully everything goes well in the live stream as well as the contest too.
Okay.
Yeah.
Hello, I'm Brian Tai, and I'm here for a problem hint for problem F, mice mirrors string. Let's take a look at the description first. Okay. The description of problem F is as follows. You are given a string S consisting of digits 0 to 9, and you want to use the string to generate a variant of mice split per grid. In this variant, a cell may contain more than one mite, and the mite the mite count in the cell is based on its 4 neighborhood instead of the usual 8 neighborhood. To create a mice split per grid, you should choose a weight W and split the string into W digits per row. And after the grid is created, each cell will be replaced by the number of mice. Those empty cells will be replaced by the mice, number of mice. And you need to calculate among all the weight of the grid, find the case largest sum of cells numbers. For example, if you have a digit string like this, and you choose weight 2, then first you need to split the digit by 2 digits per row, and then create a grid like this. And for this empty cells, you need to replace by the mite count and should replace this by 2, and the final mice split grid will be represented at this kind of looks, and the sum of number will be 3. So you need to enumerate all the weights and try to output the case largest sum. Okay, that's the description of this problem. How to solve this problem? You might think that directly counting all the numbers, all the sum might be harder. So we can assume that each mite will contribute 4 to the total sum initially, and we will try to decrease the total sum after some process. And the solution has several cases about decreasing the sum, and some of them is like if you split the mite at the bound of the wall, like the upper wall, the left wall, right wall, and the lower wall, then your total count will be decreased by the digit sum, the digit itself. So you can use some trick like in number theory to try to count for each W. The hardest part of this problem is like if you have 2 mice, and if, for example, there are 2 rows and the mice appear here and here, so that their contribution will conflict together. And you need to decrease the total sum by their sum. How to solve this case? You can observe that if they got conflicts at the mite originally at position I and J, then they will be conflict at the weight W equals I minus J. Take their absolute value. So try to look at this formula and you can find that, maybe for each W, we can count how many pairs of IJ, both of them are mice digit, and the difference is exactly W. And that is a classic convolution problem which can be solved in analog and time. And there are some details in that you cannot just count the pair because you need to decrease the total sum of these 2 digits. So you might need to estimate carefully about the numbers on the polynomial, so that you can multiply 2 correct polynomial and try to figure out each contribution of each weight. So that is the simple solution guess of problem F. Thank you.
Okay, so thanks Brian for the problem solving hints on problem F, and we will directly go to our session within 2 minutes for our chief judge's interview. So thank you, Brian, again, and thanks for the problem solving hint. Yeah,
Thank you.
thank you. Scoreboard 在上面 ，Scoreboard 在上面，我的画面在右上就好了。然后等一下 Chief Judge 来再把我的切下来。Okay, so the team Fluxus Q for KIST just solved the problem D, and that is their ninth solved problem, and currently up to second, but still a little bit far of the penalties. At the top of the standings, we have strong zero for the National University of Singapore, and their direct opponent, Penguin and Tonic, is currently at 7 problems. So the gap is closed down a little bit, but still a high mountain to climb for the team Penguin and Tonic. And our chief judge has just arrived in our room, so we will invite him to the interview. Peter, you ready? Yeah, you can come. Yeah, we're ready for you. Here, this seat.
So, do I need to use the headphone? Okay, now it's on.
Okay, so we're very happy for to have our Chief Judge Peter Rosmanis here and for the interview. So maybe we let Peter to introduce himself first.
Oh, okay. So, hello everybody. I'm Peter Rosmanis. I'm a professor of theoretical computer science in Germany, in Aachen. Originally, I'm from Czechoslovakia, but I've lived almost my whole life in Germany. So, back at home, I'm a coach for our team from my university, and they participate in the European regionals. And here, I'm often visiting Taiwan with my research partners here, and we found out that we are both interested in the ICPC, and that's my connection here to the Asian region. And for me, this is a very good opportunity to be able to participate at the ICPC in these two roles, at coach at home and as a judge here,
Yeah.
which otherwise would be kind of not possible, I guess.
Yeah. So you just mentioned that you've been a coach back in your country in your university. So we're sure that you must have seen like many of the contests in Europe, right? How do you find the like problem setting philosophy in the Europe and Asia Pacific difference? Like, is the Asia Pacific style more aggressive or perhaps more constructive in nature, or do the problem sets in Asia Pacific lean more toward heavy implementation math or more classic data structure driven set?
I think the official regionals in, let's say, in my region, which is the northwestern European region. So our regional contest is called NWORK, Northwest European Regional Contest. But in Europe, we have kind of 4 regions. The style is very similar to here. Actually, we don't have regional contests in the countries, at least not official ones, but there are unofficial ones, and many universities are using these unofficial country regional contests to select their teams that they send to the regionals. And they are in Germany a little bit different, more implementation oriented and less theory and less math. So this is, for some, it's a concern, because then they don't get the optimal training for ICPC. But for the NWORK and here, this is very, I would say, identical.
Identical.
Well, from the style, yeah.
From the style. So more math and more implementations back in your country, or not the country, maybe regional.
Yeah, this sub-regionals, let's call it like that.
Sub-regionals, yeah.
They are more implementation-based. So maybe less mathematical or so.
So I wonder if that influences that, because you're being the chief judge here, well, you would have some influences to other judges and probably even the problem setters, right?
Little bit.
Little bit. So does that influence how we set the problems we like organize a problem set or?
No, actually, I have more contacts here than back home, I would say.
Ah, okay. So, well, I think maybe we should look at the problem, the whole of the problem set. Our first judge here, Pekatan, earlier, he gave us some analyze about the easier problems, the medium problems, and the hardest problems. So for the easiest problem, H, J, or K should be J or K. He said that it was expected that one of them is being solved under 10 minutes. But we know that in the regional contest, which is a level prior to the championship, many regions have problems that got solved within like 1 or 2 minutes. So
Correct.
does that 7 minutes live up to your expectations that the whole of the problem set had a little bit higher bar?
It's definitely a higher bar. In the regionals, there are usually 1 or 2 very easy problems, and we didn't have them here. So the sticker problem, the K, might have been the simplest one.
Yeah.
And if I look at the scoreboard, there's still one team that hasn't solved
Yeah,
it, and
there is one team.
and there are some teams that took very long. So it's definitely not as easy as the easiest problems in the regionals. But the reason is, of course, that almost all teams here have already
Yeah.
among the
already-
best teams in the
Yeah,
regionals.
because to be here, they needs to be in, like, let's say maybe top 8, top 10, top 12 in
Right.
the regional contest to be here. So still we have a team unable to solve any of the problems, including problem K. They got 3 unsuccessful attempts. So what could be the trap in that problem that it's taken them so long and still not able to get on the board?
Yeah, this is hard to say, but the problem is not completely trivial. Maybe they are just unlucky. I don't really want to speculate about this team.
Okay.
Yeah, to be honest, I haven't looked at their submission, so I don't see.
Yeah, understandable because you will need to be taking care of the, let's say, top 12 teams or top 18 teams, or maybe top 20 more, and also the harder problems where the teams are getting maybe wrong answers or probably unexpected results. So, yeah. Currently, we got 3 teams and 9 problems, but the problem sets that solve are identical. Only A, G, L, and M are left. We already know that these 4 problems are the hardest 4. But do you expect that any one or maybe 2 problems of these 4 can be solved within 5 hours mark, or even before the frozen scoreboard, because it's going to be frozen in 12 minutes?
Yeah, I think now I would predict that no team will solve all problems.
Yeah,
That-
but if 1 or
but-
2 maybe?
Yeah,
All of these
I
4?
hope so.
Hope so.
Yeah, I'm very surprised that A doesn't get solved.
Well, we know that A is a interactive problem. Of course, we will have judges to come later to give our hints to the problem to problem A.
Yeah.
Yeah.
And G, I'm also very surprised. I was suspecting that this will be solved more often. And now it's solved 0 times.
Yeah.
L and M are very hard. They should be solved at the end, I would expect.
Yeah.
But now they are struggling with A and G, apparently.
Okay. So, well, okay. So we now know that the champion in this contest could be solving just 10 or 11 problems out of 13. The judges actually, we know the judges predicted it could be 9 to 12, but we also know that more judges voted for 11 or 12. So 10 or 11 for now seems a little bit under expectation.
Yeah, exactly.
Do you think that this could affect this team's, let's say, confidence going into the World Finals representing our super regional, Asia Pacific?
I don't think so. They realize that this is a hard problem set.
Yeah.
I would have expected, well, it's hard to say, but of course I was hoping that one team can solve all problems, but that's
But
too optimistic, I see.
because we know that to solve hard problems, first you need to solve the easier ones, right?
Right.
To go to the hard problems, because each problem counts as the same. One problem is solved. So the difficulty rating of the easier problems also would affect this. Well, but we do want to know that if there is a problem or maybe two that maybe hasn't been touched yet, and you are excited to see if there is a solution for that, regardless if it's a accepted solution or not. I mean, of course, if it's not accepted, it has to be closed. But do you have any one or two problems of this kind?
Yeah, A and G, I would.
A and a G.
A and G. So I'm pretty sure they will be solved by the end of the contest. Yeah.
That's a lot of confidence.
Yeah.
At the scoreboard for
Okay.
now.
Yeah. Yes, but I think so.
Yeah.
They are working now, right? They haven't given.
Yeah. For sure, they are working now.
They haven't given up yet. So
Yeah.
I'm also hoping maybe. Yeah. So that's 3 teams now that have these 9
Solved. Yeah.
solved. I don't know on which problem they're working, but I guess A and G, and they will be solved. But maybe somebody's working on L or M.
Yeah, probably because we don't know what they're working on
No.
yet.
Now you see something is happening on the
Oh
scoreboard.
yeah, someone's submitting G, and that is
Fox is cute.
yeah, Fox is cute. They are not the regional winner,
Yeah, they are.
but that one is a wrong answer.
Oh, too bad.
Maybe
Yeah.
we can. Yeah, our chief judge is here. Maybe we can have some privilege looking at how many test data they passed.
Yeah.
Let's just given.
Yeah.
Yeah,
Let's-
just give it
Yeah, sure.
like
sure.
percentage or
Yes, like
yeah,
let's-
how close they are.
Let's see. Wait. Oh.
Far from that.
Yeah, they can't hear us, but yeah. So it's the same as the first submission.
Yeah.
There's one sample that was correct, of course, but
Yeah.
the first.
First hidden
So
case is
what I could do is let the judge system run everything, right?
yeah.
Okay, let's see whether I can do that. Judge remaining here. Now we'll see. Because it failed on the first test case.
Yeah.
So why is it not doing anything? Huh? Okay. So it seems that half of the test cases are correct, half are wrong.
Yeah. How far wrong? It seems. Well,
The first submission,
Yeah.
I think this looked good to me, but let's see. Maybe I can check if we have time. They have 2 tries, the first. Okay, it takes a little bit of time,
Yeah.
but it doesn't look bad.
Yeah, it doesn't look bad. Only.
No.
No.
It looks bad.
No,
Yeah, it's
yeah.
also
Yeah.
some are correct, some are wrong. Yeah.
So it seems like some of the earlier, or not earlier, let's say that the cases that needed less time, they got yes, but the others they got it.
There's no problem with the time. It's the wrong answer.
Yeah, wrong answer. Okay. So, yeah, back to the contest itself. Well, we do want to know that is there any first to solve that were quite surprising? I mean, by a team that are not expected from the judges.
Yeah, there was something, but I can't remember now. I think there was some team, they deliberately tried to be the first to solve some middle problem. And
So
usually all teams try to solve the easy problems.
yeah, easy first.
But they had a different strategy apparently.
So maybe.
But now I can't remember which one it was.
Could it be maybe well could it be because the teams know that the top 12 are safe for getting the ticket to the World Finals if provided that they are the winning team within their institution.
Yeah, I'm not sure.
So they don't really need to go for a top. They just need to.
No, I think I can't. I'm not sure. I can't remember now. But
Yeah, it's okay.
they might also. At the beginning, you don't know which are the easiest problem, and you could pick the wrong one.
Yeah, could pick the wrong one. So, yeah.
So I was also surprised that Jay was attacked relatively late.
Late, yeah.
So this was very surprising.
Well,
But this might be some group dynamic.
Yeah, probably because we know that there are only 3 contestants in the team, and at the contest beginning, they got 13 problem statements to read. So probably the distribution took some time for them. Maybe problem J is not the first one they were able to read it first.
I guess you're right. And then they see that at the scoreboard that K is solved a lot, and then they just
Yeah.
go for K.
Yeah, probably they would just dismiss J and go for it.
So let me see
Yeah.
when J was first solved. After 21 minutes.
It was 21.
Yeah.
21.
And K was 7.
Yeah, K was 7, but the 7 was like after that accepted solution. The next accepted solution on K was at 10, then 11.
But
So
I think this is
there's-
realistic. So that's when you're very good, you need so much time.
Yeah.
So you cannot solve it in a minute, I assume. But maybe some can. I don't know.
Yeah, probably those 2-3 minutes are just time for reading the statements.
You have to think a little bit for this
Yeah.
task. It's not just reading and typing and submitting. So
Yeah.
it's not
Yeah,
not
yeah.
that easy.
Yeah, of course we're in the championship.
Right.
The problems that cannot be that easy for this top team.
I think there was in the World Finals, there was some team who solved some task in 30 seconds, if I remember correctly,
Yeah.
which is kind of superhuman, I would say.
Yeah. So
Incredible.
well, we know that the contestants are human here ultimately, so they are not allowed to use internet. So that also means they are not allowed to use AI to help them solving these problems. But we know that AI has been a hot topic in recent days, recent months, or even recent years. So with the evolution of AI and advanced tooling, how we want to know how has the judging team that did the problem solving process this year? Did the judge team use AI to assist? But also, if the judge team used AI for this, would it be a little bit too much for the contestants to cope with that?
Yeah, so as far as I know, we haven't used, and nobody of us used any AI here. But yeah, not out of principle, I think. So
Yeah,
just if I had more time, it would be fun to just test it with a local model, of course.
yeah,
But I didn't do it, and I think nobody did. But it would be an interesting
yeah,
experiment. But we can do it later too.
yeah,
And if your question is, should in the future the participants be allowed to use AI? Yeah, this is a good question because at the moment, the editors don't even have some command line completion
yeah,
automatically, which is
yeah,
maybe becoming so standard that it's kind of unusual not to have it.
yeah,
So I wouldn't be surprised if something like that would be added in the future to the system. But if it's just completion of the command line, then this will not speed up the process a lot, I guess.
yeah.
It will just save typing speed. But if there's a real AI in it, like vibe coding,
Well,
I don't
think
know.
that will be a very big difference.
it would be a different contest.
Yeah,
So I don't know what will happen.
yeah,
I'm not aware that contests like that exist at the moment, but
Yeah.
I wouldn't be surprised if something like that would be
Yeah.
introduced somewhere. So many contests now. This will certainly happen. We'll see.
yeah. So, well, well, this is a super regional contest, and well, we're not using AIs here. Then we want to know, because we know that the World Finals, it also doesn't allow AI, right? This whole contest, all the ICPC contests are not allowed. At least for the contestant, they are not allowed to use AI or even internet. They are not allowed. So we would like to know that how many of the problems today would you say really are at World Finals level in terms of complexity and in depth?
Yeah. So
Because people are not not allowed to use AI, right? So for the contestants that use AI a lot, they this could add some difficulty for them.
So the question is, which are how many problems are on?
At the World Finals level, and do this affect the contestants' performance?
I think the hard problems are maybe even maybe they are harder than we intended. So GILM. And I was solved a lot, but A seems also to be very hard. They seem to be really on the highest possible level for these contests. Yeah.
But we will have A explained later by our judges, so we will know how to cope with that problem later. So I think for the contest part itself, I think that should be it for the contest part. But we would like to know, because you're from Europe and you fly all the way to Taiwan, probably like more than 15 hours. We're not sure about it, but we are here with the best coders in Asia. We want to know that how has the local environment and the hospitality of the Taiwanese hosts influenced the spirit of this judging team this week? Because we know not only you, but many of the judging team members are also not from Taiwan.
Yeah, the hospitality here is great.
It's great.
Thank you. Thanks a lot. So we feel very welcome here.
So
this is great, and it's not everywhere in the world like this.
Yeah.
So this is really top, and thank you very much for that.
So
It was, by the way, it's 12 and a half hours.
12
the flight.
Oh, the flight. So it's directly from Germany to Taiwan.
I came from Amsterdam, which is even a little bit farther.
Yeah.
But I was surprised. It was very fast.
Oh, yeah. Because you can just drive directly to Amsterdam, right?
There's a train connection.
Train. Yeah.
Very, very convenient.
Yeah.
And the train in the Netherlands, they are really great.
Yeah.
And you can rely on them, and the train goes into the airport, and you can just go to your gate. It's very good.
So do you know that from the Taoyuan airport to here, you can also just take the MRT?
Yeah.
The same as so you just walk to your train station back in your home, and then the train takes you to the airport and fly, and then another, not the train but MRT.
Yeah, it's very convenient.
Yeah.
I can remember the time when I went to Academia Sinica, for example, from the airport. It was kind of complicated.
Yeah.
There you had to take shuttle bus to the high-speed train, and then subway, and then the taxi. And today it's great. Now the airport is very well connected. Yeah.
Yeah. So would you recommend that for the Asia Pacific region or super region, that the championship should, let's say, we should have a higher percentage of the championships being held in Taiwan in the following years? Do you recommend that?
Well, I think the nicest thing is if they travel around, right?
Yeah, traveling around.
Yeah, like the championship. This seems to be really nice. It was in Vietnam, Singapore. Now it's here, and then it will be in Japan, and then in Australia.
We know the next 2 to 3 years already.
So walking around, this is the nicest thing, I guess.
Yeah. Okay. So not just in one country, but in every country.
Yeah.
Okay, that's great.
Sometimes in Europe, with the regionals, it's a big problem to organize it, and it's always a big struggle to find somebody who will organize it. So now, for example, my regional, it was in Delft 3 times in a row, and they agreed to do it 2 times, but nobody else wanted to do it, so they had to do it a 3rd time. And it's always in the same place. The advantage is, of course, that they are now familiar with the organization.
Yeah.
But for them, it's a lot of work.
I think that's a big difference from in your region and in Asia Pacific, because we know that in Asia Pacific, many countries wants to hold this championship. Vietnam, then last year was in Singapore. This year, Taiwan. Next year, we have Japan, and then many countries are trying to apply to hold this. But it sounds like back in your region, is a little bit sound like someone is being forced to even hold a regional because no one wants to apply.
It's not like they don't want to, but it's not easy. So, for example, they try to pressure me to do it at my university. It would be impossible, I would say.
But you're a coach. If you're going to hold the contest, you cannot be a coach.
No, I cannot. But
Okay.
but so if you organize a contest, you should not be a coach. But on the other hand, in my regionals, the system is kind of strange.
Yeah.
You submit your problems or proposals.
Yeah.
Some are accepted, and the task authors become automatically judges, and usually there are also coaches at the same time.
Yeah.
And you have this dual role, and you just have to not mix it, right?
Yeah.
But here it's different. It's not like that judges are also coaches. Never. Which is better, I guess. But you're right, it's not easy to find somebody. So it's not like we have 5 volunteers to host a regional and then people vote where to go. It's always a hard problem to find somebody. So now it was in Karlsruhe, and next year it will be 2 in Karlsruhe. So they do it twice. But then we don't know. So here it seems to be no problem to find a volunteer.
Yeah. So, well, we are already, we have the scoreboard already frozen, and that means we're under 1 hour. In fact, it's only 49 minutes left to the end of the contest, and we still have some problems, interesting problems. We need the judges to come and give us some hints about it. So, well, Peter, thanks for sharing the judges' perspective. We truly appreciate your time and insights you share, and we know that actually you are also super busy at the moment and eager to get back to judging, maybe.
Yeah.
Because we know there are a lot of submissions coming in within the last hour, and you do have to make sure that the results that judges are responding are correct.
Yes,
So, yeah.
you're right.
Yeah, so
the time is already quite advanced.
Yeah, so we'll let you go back to the judging room, and thank you again. So we're going to start the problem B's problem solving hints directly now.
Okay, great.
Yeah.
Thanks for having me. Yeah.
Yeah, thanks, Peter. Okay, so now we have the judge that will provide us the problem solving hints on problem B. Would you please introduce yourself briefly, and then we can start the problem B solving hints directly.
Sure. I'm Shogo Murai and from JAT, and I would like to present program B.
Yeah.
I would like to use this. I will write something on this. Oh. Sorry, could someone help? It's not selecting mode. Okay.
If it's not on, I'll click this one.
Okay, thank you. Oh, sorry. This is about game on 3, and this is a rooted tree, and each node is associated with a number, but we are only interested in numbers on leaf nodes. Like this. And two players taking alternate turns plays a game on this. And each player selects one node, such as 5 or 6, and then remove all of its descendant nodes, including itself. For example, if one selects 5, 5, 6, and 7 are removed. Oh, sorry. Resulting in a tree with 2 leaves, like this. And this, in this game, it is not allowed to select a node for which its removal will result in no leaves, such as if in this case we cannot select 2, because after selecting this there will be no leaf remaining. So after taking turns, there will be one leaf node remaining. So because in this case, one may select node 3, then it is removed, and exactly one leaf node 4 remains. The objective is that for the first player, the objective is to minimize the number, remaining number. Oh, sorry. It's eraser. Oh, sorry. The first player minimize, and second player maximize the number, remaining number. And this is the brief introduction of this task. So now can I go to the explanation of solution?
Sure.
Okay, so
Sure.
I would like to briefly introduce solution. First of all, in this task, the answer will be one number, but for simplicity, we would like to convert this task into a decision task. For example, in the graph, in the tree, as in the sample, we decided one threshold. For example, 4, and we check whether the answer can be at least 4. Sorry, at most 4 or not. I think this either will be okay. And answer, I suppose we want to check whether answer can be at most 4. Then we mark each leaf with 1 or 0 by like this. 3 and 4 are marked 1 because it is not more than 4. But 6 and 7 are marked with 0 because it's larger than 4. Then the task is for the first player, the objective is to make the value on the remaining leaf 1. On the other hand, the second player wants to make the value 0. So if we can solve this kind of decision problem, we can solve the original problem by checking all the thresholds, but we don't have to actually check all of them. Instead, we can use binary search. So now we concentrate on this decision problem. For this task, oh, sorry. Oh no. Oh, okay. Suppose we have a 3 like this and like this, and although we cannot explain the proof, we can solve this task by DFS. And for nodes with mark 1, we first assign value +1. For 0, we assign -1. And for each intermediate node, we first compute sum of values over its children. For example, for this node, the value will be -1, and for this one, +1. And the value should be bounded by -1 and +1. So for this node, the sum will be -2, but after bounding, it goes to -1. The same holds for this node, and the answer is determined by the value of the top node, top or root node. If this value is +1, 0 or +1, then the first player can make the value on the remaining node 1. Otherwise, it is not possible. This is the sketch of the solution. Yes.
Yeah, okay, so I think that is our problem solving hint for the problem B. And thanks for the hint. Shogo, right?
Yes.
Yeah. Okay. Thanks for the problem solving. Yeah. And now we will show our frozen scoreboard. Yeah. Yeah. So now we will show the current scoreboard, but it is frozen, and we will invite the next judge to introduce problem A and M.
live streaming room, and now we have invited another judge. So, he would like to present one of the harder problems. Are you gonna reveal what problem it will be? No worries. Later.
So I'm the author of the problems A, B, and L and M, and unfortunately, three problems A, L, M are not solved yet. But anyway, I want to talk about the very brief overview of problem M.
So, before we start, do you want to introduce yourself?
Okay, I'm one of the judge in Asia Pacific Championship from 2024, and I'm serving as the one of the judge. And my name is Mitsuru Kusumoto, and also what to say? Yeah, that's it. Yeah.
Yeah. Okay. So let's start with the problems.
Okay. So in problem M, we consider a sequence of parentheses. So I think the concept of the sequence of parentheses being balanced is somewhat very popular. Its formal definition is kind of like this. But in this problem, we consider somewhat different variation for that. This is the above one is a balanced formulation, but in this problem, we also consider something a little unusual because I wanted something strange.
Yeah.
Yeah. So this formulation looks somewhat
It's quite different from the top one.
yeah, random, but in the problem we say that this formula is deformed.
Yeah.
But we can think it simple way. So let's consider a little different formulation. Like this. So the terminal symbol is replaced lowercase letter r.
Yeah.
So for just a readability. And then the two terminal symbols are replaced different brackets.
Yeah.
Then I need prime. Then the E prime, if the string conforms to E prime,
Yeah.
then it looks like this.
Yeah.
This means that the brackets must be balanced in a normal sense if we exclude the lowercase letter r.
Yeah. So the R is like the things in the parentheses.
Yeah, yes. R is between the parentheses, brackets, and
Yeah.
then it flips the direction.
Yeah.
And this is a necessity and sufficient condition of the string being deformed.
Yeah.
And from this observation, we can do some case analysis to solve the problem.
So what will be the cases for this alternative formulation?
So cases. So in the problem, we need to. We are given some string,
Yeah.
and we will append a string. We will prepend and append a string so that the string becomes deformed,
Yeah.
and also the string plus closing
parentheses
Is balanced?
is deformed.
It's deformed. Oh.
Yeah.
Yeah.
Yeah. So because the R, the existence of R flips the direction. There is a discussion about the parity.
Yeah.
Yeah, that's the part of case analysis.
So this problem is like you're going to think this alternative formulation, and now that will become more clearer to you that you will need several cases to actually solve the problem, which is more intuitive, right?
Yes.
Cool. So the problem is just you're going to find the minimum to make it it is deformed, and it adds one right parenthesis is balanced. So do you want to talk about how to get the cases correct, or what are the cases?
It might be a little complicated, but it turns out that so given string, if the given string is S,
Yeah.
what we need to prevent can be only three cases, like I might be wrong, but
Yeah.
so some amount of opening parentheses
Yeah.
and or opening parentheses, one closing, several opening, or several opening, one closing, several opening,
One
one closing, and these three cases are enough to consider.
to consider. So that's for the left part, right? Yeah.
Yeah, yeah. For the left part, we can determine the minimum number of ranks deterministically. Yeah.
Yeah. So, so you can, when you figure out the case for the left part, you will know how to complete the right part, right?
Yes.
Yeah. So that's an interesting problem. So you have really interesting parentheses grammars.
Yeah.
Yeah. Do you have like anything to add for this problem, or you can like briefly discuss or comment on the other problem, which is A and M, right?
A and M. So how to say? So for problem A, if the query A is a interactive program that needs to determine the suffix array using some query.
Yeah.
And if the query limit is n log n, it is a very trivial problem.
Yeah.
Yeah. Classic sorting is okay. But in that problem, it is the query limit is 6,000.
6,260.
Yes, it actually means n log the number of alphabets.
Number of alphabets.
26.
Yeah.
Plus some garbage factor. Yeah. Yeah.
So it's going to depend on the number of alphabets, right?
Yes, and I think that's challenging good part.
Yeah, because if you just sort it, you will need like 10,000 queries, which is too much, right?
Yes. And for problem L, so we are given many points, and we need to take convex hull and remove the boundary points, and take convex hull and repeat that.
Yeah, that's an interesting problem because you have both number theory going on, and so the problem is you have a set of points which is given in the form of ax plus b modulo m for each single integer x. A, B are two given inputs, and you're going to take the convex hull and output the doubled area of the first k convex hull, right?
Yes, yes.
So, do you think? Do you have like anything to add to the problem?
So the very outline solution of that is that so we are given n points, but we can group square root n of line segments,
Yeah.
so that taking the convex hull can be done in square root n time.
Oh.
So one operation is square root n.
Yeah.
So we can solve it quickly.
Cool. So, do you think like how many team will solve any of them? If you have to guess, like.
I wish at least one team
Yeah.
solves
Yeah, I
some
think-
of them.
Yeah. If there are no teams solving them, like the championship is going to be, it's going to be really crazy because they have a lot of time for these problems.
Yeah.
Okay. So thank you for your presentation and thank you for coming to the judge room. And I think that is most of the analysis for problem A and L and M. And thank you again for coming to here.
Yeah.
Thank you.
Thank you.
Okay, so now we are back in the streaming room, and the scoreboard has been frozen for 40 minutes. So there is a lot of things. There are a lot of things going on the scoreboard. So one thing I'd like to say is like just before the scoreboard was frozen, I saw Strong Zero is trying to solve A. Although I cannot now share their screen because the scoreboard is it's frozen. So it defies all of the it defies just the meaning of freezing the scoreboard. So, but that means they probably could solve at least one problem of A and M, which is supposed to be the hardest problem in the problem set. Yeah, and now G has like surprisingly less some pending submissions than problem A, because we see drop table teams, which is the South Pacific region top teams, they are submitting A, and Strong Zero is also submitting A, STAB is also submitting A, and the HCMUS type family also submitted A. But G, we have already see the very early wrong attempt from Just Use CRT, but they seem to already abandon the problem. We are not seeing any more submissions. Let's get the scoreboard rolling and see if we can find something interesting, because that will also depend on the bottom teams, because they are going to compete for either the silver or bronze award, or they are going to maybe compete for the world final seed, because we see a lot of duplicated university at the top, and also Just Use CRT already got a seat to the world final. So we see the Revenge of Shinchan submitted all of the problems. And now there is a trick. After the scoreboard has frozen, you can submit a compilation error to the judge. So what you're going to do to submit a compilation error is you just submit any garbage to the judge, and it will be considered as a pending submission. And I'm not sure if that's in the rules or that's in the Dome judge's bug. Oh, sometimes you just submitted M again. Okay, so but what that means is some of the pending submissions might not be real. So if you see someone pending, and in the solver it's disappeared, then that means someone submitted a compilation error. So, but that's going to, the first thing is that's going to take you some time. And the second thing is, if you're going to submit every single of the problems, like other teams will probably not trust what you're doing next. So do you have anything to add to the Revenge of the Shinchan team?
I even have 10 submissions to problem C.
Yeah, they have 10 submissions. They're like, that seems like 12 submissions to problem C.
Oh.
So like C is like really tricky, but maybe at this point, because the teams with 4 problems solved there are so many teams with 4 problems solved. So getting a problem correct is a massive for every single team down there. Oh, Fox is cute. Oh, Fox already submitted G. That's then submitted G. They submitted A and D and G in it's like 1 minute. That's insane. Are they trying to submit like every single? They just submitted I. It's submitted L. It's like caught in 4K. They are doing the same thing as the Revenge of Shinchan. They submitted M. They submitted. This is like virtually every problem.
Yeah,
They submitted virtually every problem left. So clearly they are going for C, right? Because they have 12 submissions. So we don't know. Maybe they got I or G. Maybe they are going insane. They're going A or M. So A seems more approachable because from analysis we know the A problem is you are given there is a string with its in lowercase Latin alphabet, which is A to Z, and the string is hidden from you. You can only interact with the judge, and the interaction is quite simple. You just ask. You're going to find out the suffix array, which is all of the suffix. So it's sorted according to the lexicographical order, and you can query is like very straightforward. You can query 2 positions, and the judge will tell you like which is smaller, but the judge won't tell you what the string is. So it seems like more and more standard problem, right? Yeah. So, but G we're seeing early submissions. So now StrongZero submitted M again. What is going on that problem? We cannot see it, but they got 5 submissions in M. I mean, they have an enormous penalty advantage. They are over 200 penalties ahead of the second team. That essentially means they can submit up to 10 wrong submissions, and they can still win it if they got more or not strictly more problem solved. So there's no pressure on StrongZero. They can just submit it again and again. Okay, now there is other things. What is this? Okay, so we have received the judges predicted. Is it predicted or just the statistics? Let me see. Oh, there are judges' prediction. So let's see. Let's put on the stream. Or okay, so this is the judge's predicted solution count for each problem. So we only have 70 teams. The judge, they think like K will be fully solved. It's like really similar. J will be slightly less. H, so like except like C, H, and JK are. No, they actually didn't. It's the contestants that there are a lot of solve of H. I think it's because it's solved so early. So the scoreboard's going to affect what the team's decision a lot, because if you're seeing H and you're going to think this is an easy problem. So if you remember, like earlier in the stream, I didn't actually get the problem fully right. I didn't prove it, but I mean, if I'm a contestant and we don't have the time or we don't have the ability to prove that's correct, sometimes we can just guess it because if it's correct, it's correct. We don't have to submit a proof. We don't need to submit code, right? So I think that's probably the reason why HKS summit is solved. But interestingly, like the judges think that there will be, it's like roughly 5. Is it 5 for? I think it's like a little bit more than 5, maybe 6 or 7 teams for the problem A. So that means but the scoreboard there is not a lot of pending submissions from A. Even counting those the Revenge of Xinjiang and Last Dance submitting all of the problems, there are exactly just 6 teams submitting to A. So maybe we'll see a little bit in the last 10 minutes, but I'm not sure if that's gonna happen. And G and L and M, these 3 problems, the judge predicted there probably will be 1 or 2 teams solving that, right? So that seems L, the Magical Fish and Amatsu Kaze from one of them from the Institute of Science Tokyo, another from the University of Tokyo. They have submitted L, so maybe there will be teams solving that. Okay, that's backed. But so surprisingly, like the D problems, which we have seen on the stream earlier, it's quite a standard problem, right?
Yeah.
So
Just also think there should be over 20 teams solving it.
yeah, but there are only
14 teams now.
yeah, there are only 14 teams now.
And 14 pending.
So maybe we will see a lot of D coming from the upper part of the team because most of the team are either missing D or missing I. So I is actually the far more harder problems, but it seems like the pending solution to both problems have like a really similar count. So maybe and like if we go back to the scoreboard a bit, let's hide this for a second. We can see that it's going to go to the top in a second. Yeah, all teams have submitted I, only submitted once. So that might be the case that because I is a counting problem, right?
Yeah.
Yeah, so it's really hard to except for like some subtle bugs like array out of bounds, it's really hard to get wrong in the counting problem because the samples is really strong. Like oftentimes really strong. So these teams are either just submitting a wrong, they could be submitting a wrong answer for faking they are solving the problem if they don't know the compilation error trick. But I think I will say at least half of them probably already solved I. But for problem D, we're seeing like some teams takes like more than 1 tries. Like for example, just use CRT it took them 3 tries, and SSQS also needs 3 tries to get a problem, and this is a data structure problem. So maybe teams are not easily to get that correct. Okay, so virtually top 4 teams have submitted M. So M is a problem that we just seen is a really cool parenthesis problem. It is, I think at first glance, it's like really strange. The definition of that is really strange. But what do you feel after the analysis?
I don't believe I can think this is a doable problem.
Yeah, it's really scary.
Yeah.
So
he said there are 3 cases for a prepending string. So this is a somehow casework problem.
yeah, it's casework problems are really tricky because if you miss one case and you
Yeah.
think that that is going to be the problem is going to be really devastating because you're going to get a lot of wrong answers and you don't know why. So we have just received just UCRT submitted M again, and 217 I remember is a team from the University of Tokyo also submitted M, and PC Komachi decided to try on L, which is uncommon for the top teams, right? They didn't solve I and they decide to do L. Drop a table team submitting A again. I think maybe Strong Zero have already solved A because they have submitted M like a lot of times. But it could also be like they got it wrong and it's completely wrong, so they couldn't attempt because you have to come up with another solution. But I think that case is like really rare. So let's see, like there's an optimistic scoreboard, but I think I won't show that because the live system's optimistic scoreboard works. They assume like every single submission of each team is going to be correct. So that means Revenge of the Xinjiang will be the top team in the optimistic scoreboard, and the pessimistic scoreboard is just assuming every single painting solution is wrong. So I think it's better to actually analyze like what are possibly the solves. So B is a game problem, which you can also get it wrong, but it is really common for game problems to span through the scoreboard because game theory is like a really sometimes it can go really ad hoc. So sometimes you're not seeing top teams getting that immediately, but someone on the bottom will solve it. But we also submitted M. So M is like a more approachable. But interestingly, if you have looked at the online mirror, you can see that the problem that has the most solved among A, G, L, M is in fact problem G. But I'm not sure what is in the problem G because problem maybe it has some part you can just copy paste the template, so it's gonna be solved like very quickly. And L has almost no solves on the online mirror. So if PC Komachi did pass L, that will be a really impressive performance from them. But in that case, Penguin Tonic doesn't have any painting solutions, painting submissions. So they have to do something, or Strong Zero is going to take over their ticket to the World Finals. And SD ABS has 2 painting solutions, even if the L from PC Komachi did pass, they probably need another one because they have a slightly higher penalties, right?
Right.
So that means, given that HCMU is Thai family, which is surprisingly not any of the regional champions, is getting a really high spot in the scoreboard. And suppose that they did solve I, that will give them a much higher place. Okay, just use CRT goes back to attempt their problem G, and they didn't submit problem A, and that's going to be the last 3 minutes in the contest. So I think the scoreboard will probably still update after the contest last 5 minutes because I think one of the teams has faced some technical difficulties. So do they have like extra time or not? So we'll probably stream past these the main contest for a little bit to see if that's the case. Okay, we see submissions going crazy as the contest is approaching to its end. 217 submitted M again. So this is, I think that will be really interesting to watch the Scoreboard reveal whether do they get the problem M correct, because it's a casework problem. So it's really hard to guess which one are passed. And problem L. If they get problem L, that could, Vocals are also submit problem L. Is that gonna submit like every single problems, or they are just, I don't know. That's because they just submitted M and they have 2 other pending submissions. The problem. Okay, it's. Okay, Fox execute submitted K, submitted M again. Sorry, Miracle Trial submitted K. If they, what's happening to them? They actually have another submission pending. So, this it's going crazy. PC1 is submitted I, so that could be 2 problem pass if they does have I solved. Just use CRT M again.
Hi.
No talking.
Because the contest is over, but they are still in the contest hall. So let's see some last submissions. Just use CRT submit M. SEA is for L. Magical Fish is also going for L. SEA is going for L. That's 3 pending problems from them. A, L, and M, right?
But they submitted L twice.
Twice. I mean, a submission is a submission. If you don't submit any problem, you'll probably get none of them correct. So that's a reasonable attempt. Bogles or submitted G. So these hard problems, I think maybe the judge will be correct. That will be solved by some of the teams. So I think the contest is over, right? But the contestants are still in the venue. Okay, but yeah, since it's over, I think we will probably end the stream soon. So after the contest, we will start the closing ceremony also on live stream, which is like in 4 p.m. Taipei time.
Oh yeah, 4 p.m.
Yeah, so stay tuned to watch the closing ceremony so we can find out which team which team is the ICPC Asia Pacific champion for this year, and also for other teams, which team will go to the World Finals. Although I don't think that will be revealed today because that's up to the headquarters. Yeah, so don't forget to watch the closing ceremony stream for the scoreboard reveal. And thank you everyone for watching the ICPC Asia Pacific Championship contest live stream. If you like this content, you can consider subscribing to the ICPC Live so you will get a notification for every single like these Super Region Championship lives. So that will be today's stream for the main contest.
Okay, thank you.
Bye bye.
Bye bye.